Okay, we are live. Are we? We are totally live. Hello, people. Welcome to the final Niagara stream for the year 2024. Holiday season is upon us. Let me take a couple minutes to sort of talk about where we stopped last time, but also in general. It's been like what, 8 streams or so in this new era of ray tracing for the Niagara project, and so let me talk a little bit about where we are, where we need to go from here, and where and what we will do today. As usual, please write in the chat if there is sound issues or video issues or whatever. But so this is kind of where we were last time. I tweaked a couple things off stream, and I did it kind of poorly in a couple places, so I'll need to think about this more offline. But over the last few streams, we have loaded the GLTF scene with materials and textures. We have plugged in ray tracing, and then we did shadows, and then we did shadows with transparent objects. And all of this works reasonably well. So I can disable shadow blurring so that you can see that shadows from the objects with alpha testing actually work. I can enable it, you see nice blurring. In some areas you see, I guess here it's very, very easy to tell. This shadow is from a light bulb that's like here. And so when you enable blurring, the degree to which the blurring affects different objects differs based on how far they are from the surface that they cast shadows on, which is how it should be. So things work decently well. The performance implications of using ray tracing are non-trivial. So right now we spend, let's call it around 1 millisecond in this view. This is 4K resolution, around 1 millisecond to render the scene, to lay out the G buffer and stuff, around 0.3, 0.25 to do the shading, and then like 4.5 to do shadows. And then if we enable blurring, then we spend 4.8 plus 0.3, so around 5 to do shadows. And the incremental cost of blurring is pretty good, but the shadow cost is expensive. So last time we tried two things. One thing that we tried to do is we tried to optimize the shadow blur. This shadow blur actually used to be 1 millisecond. Last time I talked a little bit about a couple different approaches to optimize this. I also mentioned in passing last time, but I completely forgot about the thing. So I mentioned in passing last time that one of the issues that we had was that we were using texture sampling hardware to do nearest lookups. And if we could do image loads instead, without filtering, then this could make things faster. But the thing I said last time, I think, was something like, oh, but for that we have to switch some binding stuff, and some SPIR-V stuff doesn't fully work, and like just didn't go there. But I completely forgot about the existence of texelFetch. And so I think last time shadow blur after the stream was actually 0.5 something milliseconds, and now it's 0.28 because I switched it to texelFetch. Which again, so I haven't really worked with shaders closely for years now, and so of course, and I haven't worked with GLSL ever. Like this is the maximum amount of time I've ever worked with GLSL on this project. So well, I mean, I worked with GLSL a little bit at Roblox, but a lot of the Roblox shading was at GLSL translated to GLSL. So of course I forgot about the existence of texelFetch. So what texelFetch does is it allows you to sample a specific texel at texel coordinates without any filtering or whatever, but it goes through, it uses the same descriptor that the regular texture fetch would. Regular texture sampling, I guess, would. It just doesn't need a sampler. So this makes it much easier to flip between the two. And using texelFetch indeed achieves the same speed ups that I was talking about like I was saying, hey, with gather, for example, we could do ultimate speed up by using all 4 results of gather. With texelFetch, all of this stuff is not necessary. The code is simpler, etc., and it's fast. There is a caveat with texelFetch about out of bounds sampling, but I'll just ignore this for now. And the other thing we tried to do on the last stream is we tried to do half resolution shadow maps, which half resolution shadow buffer, half by half, with like upsampling and stuff like this. So we tried to do this, it helped performance. There were some quality issues. Off stream, I re-implemented this a little bit to do something slightly different, which is the same in spirit, which is checkerboard shadow rendering. And it's off by default. I have this mode where I can enable checkerboard rendering. So let me flip between these. And if you look at, I'm just constantly pressing the button. So if you look at some areas, like if you look at these areas, then there is very minimal changes in shadow that you see. However, if you look at this area, presumably you can see it on stream, and especially if you look at this area, you see significant changes in shadow quality. And this is similar to what we had last time with half resolution. With half resolution, I didn't have a key to toggle between back and forth, and there was some blurring stuff that wasn't like super clear. But now it's easy to toggle it back and forth. So this is our default mode. This is with checkerboard on. So this is bad, or rather this area is always bad. So if I do full resolution shadow tracing, but then I move the camera like this, you can see that these noise patterns kind of follow the rotation. With checkerboard, you just have the same problem, but it's magnified 2x. The way checkerboard works, the other thing that happened since last stream, literally yesterday, is RenderDoc 1.36 got released, which is awesome because RenderDoc 1.36 supports capturing of applications with ray tracing. It doesn't support debugging ray tracing in the sense that you can't look at your geometry in the acceleration structures and stuff, but we don't actually even need this that much. It's just convenient to have a debugging tool fully working with our pipeline, which it does. So the way ray tracing, or the way checkerboard works, and it's going to be a little bit weird to see because RenderDoc has this feature where it fills the images with an undefined pattern, and so you kind of see it plastered all over the image. But let me try to, let me see. So if you look at like an area like this, maybe, so some of these pixels are weird because RenderDoc filled them. But what happens here is we do the same compute shader that we always had. We just run it at, half of the pixel resolution, or rather half of the pixels. And then we fill them in literally a checkerboard pattern, so we skip every other pixel. And then on the next line, we also skip every other pixel, but like offset by 1. And then on the next pass, we fill the gaps. So the first pass only fills half of the pixels. The next pass fills the gaps. And the way it does this is the same bilateral thing that I talked about last time, where you just look at the neighbors and then you blend between them based on the depth differences. So it works okay. I guess on this one, it doesn't fully reproject these 2 pixels that probably should be in shadow, but maybe they even shouldn't be. It's hard to tell because there's also geometry aliasing in the scene. So like by itself, checkerboard works okay. And the cool thing about using compute ray tracing for all of this stuff is whenever you do checkerboard in rasterization pipeline, you always have weird issues with quad occupancy because you can't actually fill every other pixel efficiently with rasterization pipeline without using tricks. You could use stencil filtering, but stencil culling, but like that doesn't always work very well. So there is like weird things that you have to do. For compute pipelines, it's much easier. You can literally just change your write pattern to write to every other pixel, but you still kind of in every thread of the compute shader, maybe I should just show the code. In every thread of the compute shader, we do the exact same thing that we used to do. It's just that we alter the positions to which we are writing and reading from to kind of stretch the half resolution thing onto the full resolution, but with a checkerboard pattern. So it's literally like a few lines of code, and then the shader that reconstructs things is simple. And then we still blur at full resolution, and because blurring is cheap now, it's fine to do it at full resolution. So the problem though is, and performance-wise is decent, I would say. So like on this view, we have 3.86 millisecond at full resolution of shadow tracing, and 2.46, let's say, at this half resolution like checkerboard, right? So it's not quite 2x. There's the reason why it's not quite 2x, which we might explore on some streams in the future. It's difficult to debug because it involves essentially having some rays in the picture taking way longer to trace, and this results in utilization issues on the GPU that I'm not honestly super sure what to do about, because it's kind of not our problem per se. It's a byproduct of the quality of the deviation construction coupled with the geometry in the scene. So it's like hard. I'm not fully sure what to do about this yet. And it might be very different on different GPUs. But anyway, so it does help performance, but unfortunately it takes our existing aliasing issues with blurred shadows and makes them way worse. I should say if you don't do blurred shadows, then Checkerboard works pretty well. I mean, you don't get pixel precise shadows. So like if I zoom in, it's going to be hard for you to tell the difference. If I zoom out, it's also going to be hard for you to tell the difference. I'm actually not sure. So anyway, like if you don't do blurring, then like Checkerboard works fantastically well, especially at this resolution. But if you do blurring, then you are taking the existing aliasing issues that we have that are due to the regular noise pattern that we're using, and you're like magnifying them, and that's bad. So all of this is not great. There are ways to improve these in isolation. For example, you can do better noise, but to do better noise, you have to do a better denoiser so that you don't... Right now, the good thing about our picture, at least, is that outside of... Well, even in this area right now, so like in this view, it's mostly stable when I rotate the camera. There is geometry aliasing here, which is not ray tracing specific, but the shadows look okay. Some views like this view right here, shadows look bad. This is because the width of the blur just isn't enough to blur the individual samples like well. So there's ways to fix a lot of this stuff by writing different denoiser, etc. But the other thing that we have is we have aliasing issues on geometry as well. So for example, if you look here, if I move the camera, there's a lot of aliasing. If you look here, there is aliasing. These have nothing to do with ray tracing. They don't even have anything to do with specular. It's just geometry. If you look there, far in the distance, all of this stuff is really horrible. And again, it's mostly not specular. Well, I can't show you that it's not specular very easily, but whatever. Just trust me, even if you disable most of the shading here, it's still bad. So, the only realistic way for us, we are rendering at 4K. 4K with MSA is kind of suicide, especially given the fact that we have a G buffer now, so like it's all bad. I don't want to do MSA for many reasons, but one of them is just it's too much bandwidth and stuff. So I think the only option realistically that we have for fixing geometry aliasing is to do temporal anti-aliasing. I'm not super fond of this, as I mentioned on the stream before, but I think we have to do it. If we had temporal anti-aliasing set up, then I think we could do checkerboarding better, because we would be able to fix these issues in checkerboard mode by having access to the previous frame traces and doing the same type of reprojection. And then if you look at the interesting denoisers, a lot of them are a lot of them need like motion vectors and stuff like this. So it's kind of time for us to start doing temporal anti-aliasing and then other stuff around it. But we have a scene where no objects move. We could do temporal anti-aliasing without any objects moving, and it would still make sense because when you move the camera, you don't want ghosting around objects that move, that kind of shift on screen. So like we still need this, and we could just do this. But it's also weird to do TAA in the world where no object moves, because you technically don't even need velocity buffers at this point. You can just reproject pixels and stuff like this. So I figured it would be a good way to end the year on a slightly less sort of in-depth topic where we just make some objects move. So offline I hacked, I had some issues with GLTF, I think I'm going to replace the copy of the scene that we are using at some point, maybe over the break, maybe like next year, to a slightly better variant that has fewer like normal compression artifacts that I think I talked before about on stream, where all of this stuff is pretty bad, but it's just a scene. So I found a better copy. I think I can transplant this, but for this copy, there's problems with Blender interchange and GLTF, but I think I kind of hacked a version yesterday of the scene that should have the animation of this bike. The animation should look like this. It's very sophisticated. I placed 4 keyframes, and then I spent like 2 hours fighting with GLTF tools. So that was fun, but I think a lot of this is due to this scene being kind of odd. It uses legacy specular workflow. Blender doesn't work with it super correctly when you import and export. There's some other stuff around the scene that we're breaking. So like I think these issues are hopefully going to be fixed for a new copy of the scene. We'll see. But anyway, so there is this bike. And I think I managed to merge semi-manually this animation of this bike into the scene that we are looking at right now. So in theory, we should be able to take this animation from the file that we are loading and play it back. And the reason why I want to do this, though, is not because we really need GLTF animations or whatever, but it's because it forces us to work through some of the things that we have been ignoring. For example, we don't have a way to update an object transform, or once we do update the object transform might change, but the ray tracing transform of the object will not change because that's a separate acceleration structure. So that we have to update that, and then it would be nice to not do the current CPU sync thing that we do. So maybe we'll manage to also get to fixing that today, we'll see. But so like the ultimate plan today is to take this bike and make it rock in the scene. And the animation code that we will write for this is going to be kind of sketch, because I want to spend the minimum possible amount of time doing that and the maximum possible amount of time changing the rest of the code to allow for dynamic objects. But yeah, that's kind of the plan. That is the plan. And then hopefully that'll leave us in a decent enough shape so that next year we'll start thinking about TAA, motion vectors, and whatnot. I don't love the fact that we have to go there, but I think we have to go there in the sense that if the theme of the series is to explore modern rendering, unfortunately modern rendering is kind of unthinkable. Like you can't think of modern rendering, I think, without some sort of TAA. We'll try to make it as minimal as possible. I found a good paper from 2017 from the authors of Horizon Forbidden West or whatever it was called at the time, but Guerrilla Games. They have a very, very minimal TAA setup. They had a very minimal TAA setup back then. I'm not sure what they do now, where it's just 2 frames. So anyway, we'll see what happens. I dislike noise, temporal noise, and ghosting. And so I'm worried that it will take forever to get to a place that I'm personally happy with. But like this, I am also not personally happy with. So I'd rather see stable shadows here in exchange for a little bit of ghosting somewhere or something like this. versus what we have right now, which is a lot of aliasing in geometry in the distance and aliasing in complicated shadow situations. Anyway, that's the plan. And we will see how far we get to today. Hopefully it's going to be fine. All right. So, and yeah, if you want to look at checkerboard code, it's just on GitHub. There is a button you can press, which is X for cross, to toggle it on and off dynamically. Yeah, so fortunately I don't need AO maps, but unfortunately the GLTF scene that I'm using right now is the original the NVIDIA sample scene basically, and I can't, if I import it in Blender and export it back, it breaks. And so unfortunately I can't right now. I'm in a state where every small tweak to the scene that I have to make, I have to patch the file myself. Like the scene didn't have cameras and light sources. I added a camera and a light source for sun, and I had to do it manually. And similarly, I had to patch an animation data manually. So we'll see how that worked. But because of this, I want to switch to a different copy that will hopefully be better. And also, I think that copy should use metal roughness workflow, which is great because we need to do better BRDFs, and to do that, I want metal roughness workflow assets, so hopefully things are going to be better with the new assets. But I had zero time to do any of that over the last couple of weeks, and so I just did something yesterday night. To the extent that I succeeded, we will find out. Okay, so the first project is we need to at least get the animations from the file. Fortunately, the library that we use, GLTF, parses all of this for us. Unfortunately, the way animations are represented in GLTF scene are general. And I don't want to do the same general thing. I don't want to do like the best possible version of the animation playback right now. I want to do something super dumb that sort of kind of works for our scene, and that's it. And then we can improve it like later, however. So, all right, this is garbage. The thing we will do, so the main thing I want to avoid is the animation in the GLTF file is a bunch of tracks. Every track is a spline that has inputs and outputs like timestamps and keyframes, or keyframes where every keyframe has a timestamp. And then there's cubic spline interpolation that requires you to process tangents and do Hermite interpolation. Like there's a lot of stuff that I just don't want to ignore. So I want to only for now support sampled animations that are sampled with a uniform frequency. Fortunately, that happens to be how Blender exports animations by default, and also that happens to be how GLTF Pack exports animations by default. And I wish GLTF had a bit somewhere that said my animation is cool, or like uniformly sampled. The uniform sampling is not always the best option, to be clear, but it's like the easiest option to write code for. And so I've double checked that the animation export that I have is uniformly sampled. And so I'm just gonna assume that, and then only write code to support that. And then if we need to change it, we'll change it in the future. So this is not general animation playback. And then the other thing, GLTF has animations that each animation can be played back and paused sort of in theory separately. And I will also ignore this for simplicity. So I'll just have a bunch of tracks that will just, and then there's so many things. The third thing is when we loaded the GLTF file like a few streams ago, we flattened the scene graph. Again, I don't want to deal with scene graph, but the thing is with animations, if you animate an intermediate node in the scene graph, it affects translations and rotations or whatever of the objects that are parented to it indirectly. So all of these considerations are going to be ignored. This file has animation tracks on the leaf nodes. We are going to parse them, ignore everything we don't want to deal with right now, and just play it back. That is the plan. So the animation track is going to have a reference Yeah, so it's gonna have a reference to the draw call that we are gonna animate, and the draw call has transform and stuff like this. So then it's gonna have the actual keyframes, and again, for simplicity, so it's gonna have translation and rotation. I'm also tempted, I'm gonna ignore scale, or I'll put scale here, but because we have uniform scale, we play some games with like how that is loaded from the file, and I want to ignore this for now. I think the scale is not, I can't quite ignore this, I guess, because, yeah, I can't quite ignore this, but this is fine. Okay, yeah, that's fine. So translation, rotation, scale. So then we are going to have a vector of the keyframes. And then because I want to avoid dealing with sampling and binary search and God knows what else, I'm just going to have float start time, and I'm going to have float, well, I mean, we could do end time, but the other thing we could do is, so this is the inverse frequency, I think it's usually called period, which is basically what's the distance between individual keyframes in time. And that should make it so that we can take the current time that we are rendering at, and then we can just subtract start time, divide by period. Maybe I should do frequency instead. So whatever the number is, it doesn't matter. We'll divide by period, and then we will get the index of the keyframe, and then I guess we'll get two indices, and then we'll interpolate between them. So that's kind of the simplest possible thing that I can think of that will get us something that is plain. All right, so for simplicity, let me just, these names are not quite correct, but I just don't wanna, this is gonna be the, from my perspective, this is the least important part of today's stream, but I have to do it to get something working, if that makes sense, to get something like going. Okay, so all right, so the way this works is, I guess I'm just gonna write it here. This is fine. Oh, but I'll need somewhere to, there's some subtlety with mesh index. One moment. So when we have the node, we must do something here. Yeah. Okay. Oh, and if the mesh has multiple primitives. This is fine. Let's just do draw. Let's ignore this for now. Again, I want to do this in a very, very, very minimal way, and then we'll fix things later if we need to. So because of this, I just need something like this. For every node that has a mesh, node draws. For every node that has a mesh attached to it, we'll record like the first draw that it references or something like this, and then we'll just animate that. That's good for now. So we need to start at -1, and then if we have a mesh, if we know we are gonna push a draw, let's just here say node mesh node draws of I. Yeah, okay. So that just records the index of the draw call associated with every node. It's not quite like this because there can be more than one, but for now we'll ignore this. Okay, so so the way animations work in GLTF is that you have an animation which is like a clip that can animate an arbitrary number of objects. And then inside it, you have, I forget which one is the master, the channels. You have channels, and every channel is like a track. And the track says, I want to animate this node, for example, rotation inside this node, and the way I'm going to derive the value of this rotation is using this sampler, which has the input, which is the time, output, which is the value, and then interpolation type, and then if an interpolation is the cubic spline, then output has like tangents as well as the values. So this means we have to how I'm gonna combine great, Copilot wrote a bunch of code for me. So the thing is, I need to combine the transform tracks, because for me to ignore the scene graph, I need to construct the world space position for every keyframe. And so for that, I have to group channels into groups. This is going to be a little bit more painful than I was thinking about because of this. If we had a scene graph, these things would be easier, but because I'm trying to not have a scene graph for now, these things are harder. So one moment, let me think about this. How would I do that? Yeah, there's kind of no shortcut. There's kind of no shortcut. Okay, so I think what we will do then is this. We will do this in 2 passes. So we will track what did I say is the samplers. We'll track the sampler for rotation, translation, and scale for every track, for every node. And then we will fill that in 1 pass, and then in the 2nd pass we'll go over all of these, aggregate things, and then hopefully that will work. Okay, so let's do it like this. So this is going to be samplers for the translations, and we need 1 for every node potentially. And then we are going to have the same thing for rotation and the scale. So go over all animations, and then there could be 2 animations that are individually toggled that animate the same node. We are going to also ignore all of this. Again, like we are going to substantially simplify the portion of the spec that we need to work with, just to make things, just to get things to render. So go over all the channels, get the sampler, and then so if the channel could have no target nodes, that's allowed. That sometimes happens if you animate some other stuff like properties. And then I guess, yeah, that code is correct. The code would be slightly nicer this way. And then hopefully, all right, so this fills the samplers for every node with the sampler. There could be conflicts, we're gonna ignore them, that's fine. And then after this loop, we have these guys filled with the sort of animation data. And so we can have a second loop that goes over nodes, and then if all of these are if all of these are null, then we don't need to animate this node, otherwise the node is animated. So now we can, I think this messed up in indentation, 1 second. Okay, so now we can extract the data from these. The way this works is there's inputs and outputs, and inputs are time. For simplicity, well, actually, no, yeah, let's validate that the number of the keyframes is the same. And then we will just use that. We'll just assume that like the actual values of the keyframes are the same or something like this. We can do. So I forgot. Oh yeah, this is the accessor. So we'll just grab whatever. We'll just grab the time track from n as sampler that animates a node, and then if there's any mismatch, then we'll just skip the node. So if input count is not equal to input count, then we will then we'll just skip this. Kind of want to print a warning, so let's do that. So if there's any mismatch in the inputs, this is like when you have uniformly sampled animation, then you would expect the inputs to match. Unfortunately, GLTF is a general format, so it kind of forces you to deal with the general case, which is that they don't match. But because I don't want to deal with the general case, then we will just warn about this. So now that we know the counts match, it's likely that the frequency matches. It doesn't have to, but for now we will ignore this irrelevant concerns. And then we'll just say that the animation. Oh, the other thing we need to do is if we are animating a node that doesn't have a draw call attached, then we are just gonna skip that as well. So if node draws is -1, then we're gonna skip it. So then the start time is just the first value of the animation input. So input is the time sequence. To extract this, we need to do GLTF accessor unpack floats, except that 4 is wrong. Does it even take? It doesn't take 4, it just takes this. Okay. So and then I guess, I'm not sure, I don't think input count can be 0, I guess it's fine. And then the period is the distance between the two consecutive frames. And so it's times 1 minus times 0, except that I guess if it's 1, we don't even need single frame. Let's just, I'm gonna like think about what which one of these arbitrary decisions are correct or incorrect later. It doesn't matter. As I mentioned, the goal is we just want an object to move. We don't want to care about anything else. Okay, So now that we know how many frames we have in the object's motion, we need to extract the transforms from the object. Because we don't have a scene graph maintained, we need to take these transforms for every frame, and then we need to convert them into the world space and then save this somewhere. So our animation for now is also going to be world space animation. So let's extract the floats. Let's extract the floats. So if we have the rotation sampler, the other thing I forgot to do is we need to only support linear interpolation. So let's do that here. Again, mostly because we could support like other types, but cubic interpolation requires dealing with tangents, and I'm not gonna be dealing with tangents. I'm in the mood of like just get the object to freaking move. So if we have a rotation sampler, then it contains quaternions, and then translation contains 3 floats for every object, and then like it should be self-explanatory. We can actually, this function is already like impossibly long, so we could extract this. The only thing is, it's going to be hard to write error messages. It's going to be hard to write error messages. Let's not extract it in a function for now. I sometimes do refactoring as I'm writing the code, and sometimes that's a bad idea. This seems like possibly a bad idea right now. Okay, so this should give us the values of the transforms, and there is a restriction which is, this is garbage, I think, because I think the count, oh no, I think this is correct actually. There is a restriction which is that you have to have the correct number of outputs that like matches the inputs. I believe the GLTF validates all of this. If it doesn't, it will at some point in the future. Oh yeah, so for animations it takes the components, it validates the input count, it validates the output count, but yeah, the output count is already pre-multiplied. Oh, the only thing it doesn't do is it doesn't validate the number of components for every track type. So that's unfortunate. I think I'm going to contribute this to GLTF separately, because to the extent that the loading library can validate boring stuff like this, would be good, because then you don't have to worry about this. Okay, hold on. I'm just fuzzy on the exact specifics of this. No, it is in fact flows per element. Oh yes, right. Yeah, okay, all good. Yes, okay, so actually this is correct, but there is a subtle bug here, which is there should be a validation that it's actually 4, 3, and 3. All right, CGLTF will probably learn to do this later. It's fine. So now that we have the values, what we need to do is we need to assemble them in full transforms. We already have code that can do that here. So we are just going to copy that. And then for scale, we do like the max or something stupid like this, which is fine. So we just need to do this for every frame. So and then any of these values could be, like, you could have animation and rotation, but not translation and stuff like this. So the way we are gonna do this, I think, is we are gonna copy the node that we are working on right now. Yeah. And then we are gonna just patch the values that we have in that node with whatever we have. So if we have rotation sampler, then what we need is we need to take this values and override whatever the node has right now. Node copy rotation values j times 4 for float, and then node copy has rotation should be true. Technically the node, I think this is a spec requirement. It doesn't matter. And then we need to do the same thing for the translation, and then need to do the same thing for scale. And also it's TRS, so I'm not sure why I'm processing these in this order, but it should probably be like, oh, all of this code that I've written is RTS. All right. This is a stupid consistency problem, but let's fix the stupid consistency problem so that it doesn't bother me. Okay. All right, and so now that we have the values, in theory, we should be able to just run the same code that we were running for the node, for the scene graph. And this should correctly go through the parent chain and stuff like this. As I mentioned before, this will not handle the hierarchical transformations, which, you know, is on one hand not cool, but on the other hand, that's what we want right now. So take the matrix from the node copy, extract translation rotation and stuff like this, and then this is our keyframe. And then it's translation and then rotation and then scale. Technically, because our keyframes are in world space, the correct terms are position and orientation, but maybe in the future we are gonna do the actual proper thing with animations, so let's just keep this for now. Push the keyframe and then animations, push back animation. And I guess for people who like C++, they want me to write system move here so that it moves the underlying vectors and stuff like that. I think this is kind of correct. I don't know. I'm sure there's bugs in the code, but let's run this. So, and just like the previous GLTF stream, we are starting by running the code that we can't prove works. Because who knows, we just loaded a bunch of values from the scene, like maybe it works, maybe it doesn't. Let me compile and debug just in case. So when we load this scene, we'll have this animations, and then we will load that. Okay, some code runs, it loaded 6 animations, which means animation tracks. I'm just abbreviating. So 6 I think is correct, because I think there was 6 objects, and then I'm not sure if the time and period are correct. So the only way to test this, the only way to know is to test this, and the only way to test this is to try to animate. There is a few things we'll have to do to make this actually correctly work. But in the spirit of extreme iteration speed, what I'm gonna do, so the first thing I'm gonna do is, what's the fastest actually way to, okay. I think I have to kind of do this the hard way. Well, not the hard way. So I'm gonna talk about this in a moment, but let me just very quickly try to plug this through. Wait, this is not the right buffer. Where's the right buffer? This is the right buffer. So let me just very quickly try to write the code that doesn't even do the right thing from the frame time perspective, but just like copies the transform or whatever. And then if that doesn't work, then I'll have to debug the animation code, so I'd rather talk about that first. But if that does work, then I'll talk through like what's the actual thing that we need to do that's correct. So let's just go animations, go over every animation, just take one keyframe which is based on frame index modulo keyframe size. Oh, if the animation keyframes, if we don't have any animation keyframes, oh, I already am rejecting all of this. Okay, cool. And then just take the draws, but and db data plus animation draw index, GPU draw, position, scale, orientation, except that it's translation here, and then rotation here, and this should be a reference, and this should be an interaction. I think this is fine. Let's see what happens. All right. The answer to what happens is nothing. Nothing happens. I think rotation is the thing that's actually animating there. So let me just do that, and then we'll see what's actually going on at runtime there, and then we'll talk about this. Did I not fill the draw index? I might have forgotten to fill the draw index. Yeah, I did. The values are different frame to frame, so that's good. Okay. So this was a blitz through animation loading from GLTF. So I hope the GLTF code that we wrote roughly makes sense. We just said, let's assume for every node that has a mesh attached, there's only one track that animates translation, rotation, scale. Gather them, and then go over all nodes that have any animation tracks, composite them. For every keyframe, take the values of translation, rotation, and scale, construct the world space position, translation, position, orientation, and scale, save that. And then here, what I'm doing is I'm literally patching the values that leave. So on the GPU, because we have the renderer where the data is not sort of submitted every frame, it just leaves in buffers. We have a buffer with draw calls. What I did is I just changed the buffer to still be in GPU memory, but it's mapped to the CPU memory so that there's a pointer that you can write to. And I'm just writing to that pointer. That's it. There's some issues associated with that, but and then I'm not actually respecting the animation frame time, of course. So like right now, is there a way for me to? I'm not sure if I can like make this render much slower, much faster, because it runs at like, but I guess in full screen, it still runs at 144 hertz full screen. But like, I'm ignoring delta time and stuff like this. I'm not doing interpolation, etc. So obviously, the animation sampling code doesn't fully work. But the data did get through. So the reason why I had to pair the tracks like this is because I'm ignoring the scene graph, and the reason that I had to assume no sampling, assume uniform sampled animations, is not just because I'm lazy. It's not just because I'm lazy in animation stuff, it's because I'm lazy and I don't have a scene graph. And because I don't have a scene graph, it's hard for me to individually update individual values from different tracks that have different sampling rates, because I would have to like sample them from separate tracks and stuff like this. Like it's all painful. So for now, I think this is like a simpler way to do this. Of course, it's not memory efficient, etc., but we don't care about the animation code. We care about all of the other parts of the render. Because, for example, as you might notice, the shadows on the object, the shadows under the object don't move, and the shadows on the object are buggy now. That's because the ray tracing representation of the scene doesn't have the correct data, and I can't just patch it through by writing 3 lines of C++ code, unfortunately, because ray tracing code is special. So we will need to fix that for all of this to like work in a reasonable way. Okay, so that is the first part. What about RT-based AA for geometric aliasing? Is it any feasible? So if you're doing primary rays with ray tracing, so if you don't have rasterization period, then you have alternative options, because you can jitter the rays slightly. It's sort of TA way to get similar effect and stuff like this. You can do super sampling by doing more than one ray, etc. The topic of this series in general is hardware efficiency. Ray tracing right now is not even, like, realistically, if I were to implement shadow maps right now, they would run faster, and I might be able to match the quality better fast. I'm not sure. Quality is a difficult subject because there is various aspects of quality, but for sure shadow maps would run for sure. It depends on the number of cascades that you want to update for frame and stuff like this. There is like questions about some of this stuff, but the point is, so if I run this again, go full screen, let's disable blurring just for. So we are spending 3 milliseconds right now, sending 1 ray per pixel, and doing a shadow trace. A shadow trace, okay, let me disable one more thing. Okay, this is the fastest possible thing, 2.6 milliseconds per frame. Doing a shadow trace from every pixel, stopping at any object that we could possibly stop at. This would not have worked for primary rays, so if you wanted to actually render, you'd need a different flag. I talked about this last time. It cuts performance by 50% or whatever, so it would be 4 milliseconds. Compared to that, right now, our render pass, which is doing rasterization of geometry and filling the G-buffer, takes 1. So there is a significant cost that we would pay. I would estimate right now that we would pay around 4x, so around 3 extra milliseconds per frame, by doing primary, and this is before you talk about transparency actually, because if I actually enable transparency, which our renderer is doing, so actually, yeah, maybe the correct comparison is different. Maybe the correct comparison is, let's take 3.3, and let's switch the, where is this? Shadow shader. I talked about this specific aspect last time. Would you do, you might not even want to do this like this then, but yeah, I think this is roughly, so this is roughly what would happen. So this is 5 milliseconds. I switched the flags. You can watch a previous stream to learn about this. So 5 milliseconds versus 1 millisecond is like a lot slower, right? We spend a lot of time getting our renderer, like this first portion of the frame, the non-ray tracing portion, to be pretty fast. In fact, on RADV driver, it's even faster, so there's more juice to squeeze here. Pyramid stuff could be faster, like there's stuff to optimize probably. But there is a substantial cost, right? So because of this, I have to operate in hybrid mode. I have to operate in the mode where I'm using rasterization for stuff that I know can be peak efficiency and peak quality, and then only using ray tracing for things where things get difficult anyway with rasterization. So it's just not an option. But like if you were to choose this option, then you'd have the same aliasing problems if you had the same number of rays, 1 ray per pixel. And so then your option is to do super sampling by doing multiple rays per pixel, but that ramps up your costs dramatically, right? Or you could do temporal tricks, which we have to do with rasterization anyway, right? So you kind of can't win. Ray tracing is not fast enough at all right now, on this GPU at least. I don't think it will be fast enough in the next 2 years on any GPU unless you have like a 5090 or whatever. So if you have a 5090 and you want to render like 4K Q2 RTX, you're probably in a good shape. But if you aren't, like you have to live in the world of realistic. Oh well, and also my demands for performance are stringent. 4K, and I want to render at 144. This is what my monitor renders at. And so after the tweaks that I've done right now to do the shadow trace stuff, we are already almost at the limit. We are almost at, it should be like 7 point something, right, to hit 4K, to hit 144. And so we are already almost at the limit. Now, this is because I disabled some optimizations and stuff like this, but clearly we need to optimize things to be able to afford more quality or get a faster GPU. But this is like a good AMD GPU. I like this GPU for now. So anyway, this went quicker than I was worried it would go, because my scene is correct. I didn't even know if my GLTF scene is like correct because there wasn't a great way for me to debug it. It's too large and stuff like this. And B, the code kind of works. Okay, so let me fix the I'm trying to remember what is this animation running at, I wonder. One reason why this is so fast is Copilot is on point as usual these days. So this is a 24 FPS animation, cool. So yeah, so we have to do linear interpolation between keyframes because, I mean, 24 FPS on 144 Hz screen, not great. So let's do interpolation correctly. And then I will probably actually submit this, and then we'll deal with the ray tracing stuff. Let me check. I have the old scene that doesn't have all of this garbage. Let me check that works. Just because I don't want to submit code that's like broken. Okay, cool. I think we're good. And I think I can... I need validation layers, but there's a way for me to enable them now. So I guess I can... Debug is like reasonably fast to load, but not the fastest. Okay, yeah, anyway, whatever. So let's just do interpolation. And also I want to do pause playback on animation, just so that we can press a key to like disable it and stuff. And then we will, and then I'll commit this code, and then we'll talk about ray tracing. And then after this, maybe there's also this issue of we just took a buffer and just kind of mapped it to the CPU, and it's not always the best idea, but there's caveats around this and synchronization that we are currently ignoring that I'm hoping to be able to get to this stream. If ray tracing stuff goes fast, then we'll be able to also do finally proper, not synchronized rendering, which was like a long time coming, but okay. Okay, so let's do animation enabled. I guess let's enable it for now. It might make sense to disable it by default, so that I don't. Let's disable it by default, and then we'll see. So then, whenever you press space, I'm gonna be running out of keys, but I have a future plan for this. That probably, not sure if I'm gonna do it on stream, but I wanna implement a tiny tweak bar thing myself, in like, you know, under 100 lines of code or something. So when you press space, we will activate the thing. We'll activate animation or pause animation. And then let's have an animation timer. This code at some point will have to get refactored, but so let's do animation time, and then I guess we can do that like later here or wherever. Yeah. So if animation enabled, then we are gonna do like more stuff. It's fine. A lot of this code is temporary. So whenever while animation is enabled, we are going to advance the animation time, and then we are going to go through the animations. We now need to compute the correct keyframe, and then the linear interpolation between that keyframe and the next. So the way to do that is to convert the animation time into the kind of keyframe space in the animation, like depending on the animation start and stuff. So like index, let's say, is we're going to take the animation time, we are going to subtract animation start time, and then we are going to divide all of this by animation period. And that should get us from the space of seconds to the space of frames. And this value could be like negative, I guess. And I guess if it's negative, we are just not going to do anything because the animation hasn't started yet. But if it is positive, then what we need is, and then eventually this stuff overflows, but like, when does it overflow? It can overflow. It's like not unreasonable to expect it to overflow. So I think what I want to do is I want to do an fmod in the animation space. And then after this, I'm gonna do index 0 int index 1, and then this stuff. Wait, I don't trust fmod. I don't know if I should trust fmod, but I definitely don't trust fmod to do the right thing. Like, I need to look at the guarantees that fmod provides. I don't fully trust fmod. So I would do it like this. And then we need the fraction. The fraction is, yeah. Well, yeah. Yeah. So then we take 2 keyframes. I'd have to, like, if I was writing a production implementation of an animation system, I'd need to be careful around a lot of this, because you want guarantees around some of these indices, but I think this is probably okay. So then what we need to do is we need to interpolate. Writing directly like this, there's some issues with that might happen due to some properties of the GPU memory that you have to be aware of, but I'm going to talk about this in a second. So I think what I want to do is I want to take the draw call that we have. Oh, we have the draw calls also on the CPU. We have like a mirror. So I want to update the CPU copy because here I can be reckless about the code. Oh, I guess this is, there's like a GLM, there's a GLM function called mix, which is going to do linear interpolation for us. So that's cool. And then I guess there's a GLM function called slurp. So slurp is not great. I have a blog post from years ago about why slurp is not great for performance and what you should always basically replace it with. But because we don't care and we have 6 animation tracks, it's fine, who cares? Nobody was ever fired for using slurp, I guess. So then instead of filling the fields one by one, I will use memcpy, and I'm going to talk about that in a moment. But I just want to get this code in a state where it works, I can commit it, and then we'll talk about the implications. The code obviously doesn't work. Oh, yes, I disable. This is why I wanted to enable animation playback by default, but I'll keep it disabled for now. Well, it still doesn't work. Okay, so let's see. I don't actually know that start time is correct. So let me, I should probably just use a freaking debugger, but hold on. Oh, this is because I'm using the version of the scene that doesn't have animations. Okay then. Okay, hold on. All right, okay, all good. I was like, what's going on? That makes sense. Okay, so again, this code is not rocket science. This is not like make a best animation system in the world stream. You know, you take the time, you convert the time to a space where 0 is your first keyframe, 1 is your second keyframe, etc. And then if the time is 0.5, then you take the first and the second one and interpolate between them. That's kind of it. So now we can press space, and this is probably the correct speed. Now you can see that the bike kind of slows down at the end and stuff like this. This is roughly, I already closed Blender and I don't want to reopen it, but this is roughly what Blender was doing. Okay? And we can enable checkerboard stuff now, which is gonna tell us, well, the ray tracing stuff is completely borked, obviously, but this is gonna say that there is no visible ghosting, which there shouldn't be. So once we start doing temporal tricks, we are gonna see ghosting. For example, and maybe I can enable this at some point later in the stream once we fix the shadows, but I tried checkerboard in a mode where instead of filling the gaps every frame, you just don't, but every frame you alternate between which pixels you fill. And this is kind of a stupid temporal way to do this that works great when the camera is stable, because you have perfect information, half of the perfect information on every frame, so in 2 frames it converges. But the second you move the camera, you see trails. And with this, you would have the same problem, I believe, even without moving the camera, which is kind of what we want. But so let's talk about what is happening right now. So there is a buffer in the GPU memory, and in Vulkan, in some cases, you can have a buffer that is in GPU memory that is visible from the host. This is what I have changed the flag for this buffer to. Not every single driver exposes this capability. So in theory, there is drivers that will not be able to run our code. They will just die when trying to create this buffer. I'm inclined to leave this as is for now. The way to, if you don't have a buffer, we already have to write a bunch of code where we have to upload a bunch of stuff to the GPU, right? And the way we usually did this is we have a buffer that is visible from on the CPU, which lives in CPU memory. We just memcpy stuff to it or fill it however, and then we launch a GPU command to copy the contents over. We could do that. The big issue is this. On this scene, anything that we do from this perspective is going to be fast enough. The scene has like a few thousand objects. So an object is like 48 bytes, I think, as far as the draw call structure is concerned. So if you memcpy 48 kilobytes of data every frame from CPU to GPU, like nobody will notice. However, we also have the mode of this renderer that runs with like 1 million objects. It's just the scene doesn't have 1 million objects. And I don't want to regress performance in that mode. 1 million objects is 48 megabytes of draw calls. If every single one of them is animated, then you have to copy 48 megabytes from the CPU to GPU every frame. But if not everyone is, then you don't. 48 megabytes every frame is a lot. Why do I know this? The bus that connects CPU and GPU is called PCI Express. This bus runs, let's just call it 30 gigabytes a second. The numbers vary based on generations and stuff like this. I've measured on my system at some point 30 something, 30 like 2, 35, something like that. Let's just call it 32. Let's just call it 30, whatever. 30 gigabytes a second means that it takes you 1 millisecond to copy 30 megabytes. We have like a real-time renderer that renders a frame right now every like 4 milliseconds, give or take. I can't spend a millisecond uploading the whole thing from CPU to GPU. So what we would have to do is we'd have to make a system where we can tag individual draw calls as being changed, and then we only do a partial upload, like only do a partial copy. We could do like a compute shader that does this, etc. There's like a bunch of options. But I looked at the stats on the GPU info. The desktop drivers from all vendors support this mapping mode. The only driver that doesn't support is like a Windows driver that emulates Vulkan through Directory V12. I'm sure that driver will not work for us for many other reasons. I'm just gonna like ignore this. This doesn't matter. What does matter is that the memory that you get a view of that memory that you can write and read from, but the view is usually called write combined. What write combining means is that the CPU will look at every write that you're doing, and as long as these writes can be combined in a single transaction, they're going to be written in a single transaction. But it's very, very easy to break the transaction apart. For example, sometimes on some CPUs, the rules have relaxed in recent years, but sometimes on some CPUs you might write byte 0 and then byte 2 and then byte 1, like out of order, and the transactions will get broken. And so that's going to make it slower to upload. And so because of this, I didn't want to just like write bits to the object willy-nilly. Memcpy is not a guaranteed safe way to do this kind of stuff, but it's the safest possible way that C provides to upload things to GPU. So that's why there is a memcpy here. But I think I'm going to keep this object mapped in a host visible fashion for now. One other topic of this series is we're dealing with problems when they arrive. We do not write code speculatively, assuming that the problem might happen in the future. So whenever there's a driver that we actually care about that doesn't work with this, we will rework with this if needed. But honestly, you kind of want this capability, so it's fine. The second problem that happens is, in theory, is that we are overwriting data that the GPU might be using right now, because we are writing to a buffer that is like a GPU buffer that we are also rendering from. The reason why this is not a problem for us right this second is that we actually don't have any parallelism between the CPU and GPU. This is how we wrote things years ago, and we haven't changed them since because we didn't really need to, because who cares, it's fine. But it might be good to fix this, so maybe we'll fix this at the end of the stream today if we still have time. But the way you would fix this is you'd have to double buffer some stuff, so I'll probably just have 2 buffers. And then like update the current one or something like this. We'll see. Anyway, so that's kind of good for the rasterization portion. And every other thing that we have in the renderer is kind of dynamic. We don't pre-merge objects into batches. We don't pre-record constants, whatever. Anything can change. There's some caveats. Some things are painful to change because of how I've implemented them in the past. For example, right now to make an object hidden, to make an object hidden is completely fine. What's painful right now is to add new objects, because various buffers have to be reallocated if you don't have space and stuff like this. So like a fully dynamic scene will take a bunch more work. But again, we don't solve problems that we don't have yet. We don't have this problem. The problem that we do have is with ray tracing very clearly. So let me commit this code. I'll look in chat, and then we will work on the ray tracing aspect of animations. Let me extract this. Let me commit this, and then I'll extract both material handling and animation handling into separate functions, because all of this is getting a little ridiculous. Yeah. All right. So I have to check out. This is why on the off chance you don't have this habit, before every commit that you do in Git, look at the diff. You just don't want to like accidentally commit a shader change that tanks their performance and then accidentally push it and then find out about this like 3 weeks later. Code review solves this, hopefully, but code reviewers get unhappy if they see code that you clearly haven't fully tested. And also, if you don't have a code reviewer, like if you work on solo projects or whatever, like do code review of your code yourself. The only thing is maybe we should go back from period to frequency. Who cares? I think it's day 28. It's day 28. Implement initial support for GLTF animations. We currently only handle animations of leaf nodes and expect uniform TRS sampling. Well, uniform TRS like tracks with the same frequency. And using linear interpolation only. This is to avoid the need to build a full persistent scene graph with hierarchical transforms at L. We update the draw data for every object by writing directly to the GPU memory. In theory, some drivers may not expose this. Vulkan guarantees that you have a buffer that's like device local, I think, but maybe you have a unified memory thing. I don't remember what the Vulkan guarantees exactly are at this point, but there is not a guarantee that you get this buffer. But again, we don't solve problems that we don't have. But once this is actually a blocker for us, we will fix this. Once/if. Okay, one more thing. So, and this is kind of related to the thing. I guess I already said this sort of, but the other possibility is that you could change this buffer to just live on the CPU. And that kind of makes your copy free. Like you don't have a copy that you have to do every frame. But then the issue is accesses to this buffer go across the bus, and that's very slow. It's going to be hard to measure all of this on our scene, but if we actually use the mode where we just take an object file and we instance it, then we will know that we have broken our code. I don't know why. Interesting. Let me check why that doesn't work anymore. We just have like an error. Huh. But we have no validation errors. Oh, I remember this. I hit this occasionally. There's this thing that I remember I hit this at some point on the AMD driver, and I think, oh no, this makes things worse, because if there is a GPU hang. So that's interesting, actually. Huh. I think this might be unrelated to the code that we just wrote, but maybe it is. Interesting. Is this the host visible? Don't think so. One moment. No. I think this is unrelated. I think I saw this before for some reason, but only like on the AMD driver, and so I kind of ignored this. Interesting, interesting, interesting. Let me rebuild in release. I don't want to spend time debugging this because I'm very sure this is not a new issue, and I just need to look. But it's interesting that there is a, and I think this was specifically due to, let me, oh, I wonder, I need to look at the docs. I think this can return not ready or something like this, and there might be stuff that you have to do. So you can do this. It's interesting that trying to wait for it. Yes, it may return not ready, which, because we have a full GPU sync here, I was assuming this can't happen. But that's kind of interesting. But then if we put the weight there, then it just hangs. Did this break the stream, by the way? No, I guess it didn't break the stream. So it just hangs, which is kind of wild. But maybe there's some weird case where we don't submit all the queries or something like this. I need to look at, there might be some corner cases that are weird. There might be some corner cases. So if I just ignore this, what breaks is the question. The answer is nothing breaks. So it's as if like on the first frame, it returns not ready. So that's interesting. Let's ignore this problem. Or rather, let's not fully ignore this problem. Let's add a macro that says that result is either success or not ready. And then at some point later, maybe I'll think about this further. I don't want to deal with this right now. Because if the query is not ready, even if it doesn't write these results, all of this stuff I think is like either zero initialized or just reused from the previous frame. And this data is only used for profiling display. So like the worst case scenario is we don't like some of the data. And also this is the code that we'll need to change once we actually do concurrent CPU GPU work. Sort of. It wouldn't have to change a whole lot, it would have changed a little bit. But so I just don't want to deal with fixing this in any better way right now. I'll just put, oh, asserts are off. I guess asserts are on. All right, that's fine. Yeah, we're running in debug, that's fine. Okay, okay, that's fine. So let me go to release now, and then again, so if you look at the time that it takes us right now to do calling, for example, it's like 0.27 milliseconds. And this is with this is without, like, I killed the host visible bit, right? So let's add this back. And then I think it should still be 0.27 millisecond. Let's see, yeah. So the fact that this buffer is available to the CPU to write, by itself, generally speaking, doesn't make anything slower, like it's fine. There's some tricky stuff around host caching, but if you just say host visible, it shouldn't matter. There's also another thing you might need, which is host coherent, which is the depth of Vulkan I don't really fully want to go into right now. But even if you set that, it's still 0.27. I think I might want host coherent though. Yeah. Host coherent should generally speaking be free. There's another flag, there's like a third flag called host cached. So that could be somewhat expensive. It might be free right now, it's free right now, but on some GPUs it requires extra work from the memory controller to like monitor the cache traffic, which I'm not sure if that can ever cause a performance drop or not, but whatever. So adding these flags, and we'll add the coherent flag. Have we used coherent flag before? I think we, oh yeah, we have. Yeah, okay, okay. We actually have used it quite a bit. Okay, cool. Yeah, you can use host visible without coherent, but let's not. However, if we remove the local bit, what this will do is, wow, this is like a new Z feature that is freaking annoying. Because they now do, I read about this in the release notes. I should disable this. Because they do suggestions in normal mode in Vim, which is super not what I want. One moment. Where even is this? What the heck is the GitHub page? Oh my god, people, where is the GitHub page? Oh, view changelog, okay. One moment. I swear there was a release note about this. I don't like this. Is this just show completions and input? One moment. Because it's just broken, like when I remove a piece of text that it shows me it suggests this piece of text back. That should not happen. And I swear there was a release note about this. Man, where was it? Maybe I confused it with something else, but I'm very sure this didn't used to happen. It's the first time I'm seeing this. It's interesting that there's nothing. Alright, I don't want to spend more time on this. I guess I'll just deal with this, but this is not acceptable. I will need to figure out how to fix this. Doesn't look. It can't be that. This is like a month ago. It must be super recent. Alright, sorry. Anyway, so removing device local puts this buffer in system memory. Calling is now 4.4 milliseconds. This is like worse than what I was talking about. I was saying 48 times 1 million. There's 1 million objects here. 48 times 1 million, 48 megabytes. It should take like a millisecond and a half or whatever. Our calling time just went to 4.4 from 0.3. But this is because the copy is your best case scenario where you have a giant bulk transfer that just goes from host to GPU. When you have a GPU compute shader like pulling in bits of data from the CPU memory like on demand, you're not going to reach peak performance. So it is uneconomical to read data directly from the CPU memory, but it is economical to patch data in GPU memory from host if you have a way to do this. So yeah, I need frame coherence, so let's fix that. And then I'm just gonna submit this in the previous. Also for now, work around a query not ready status on the MD.k. We need to debug it separately in the future. All right, anyway, sorry for the distraction. This editor thing is bugging me. I swear I saw a note about this, so I will just need to either look at their GitHub or just closely look at the changes. But anyway, all right. A paper on doing a few extra primary arrays on top of rasterized scene. Yes, so this doesn't fix the base cost. The base cost is still very high because your base cost is array per pixel. But yeah, with ray tracing, you can send extra arrays in disoccluded regions only. There's a paper from NVIDIA about this. But if your base cost is like 4 times, we could literally do multi-sample anti-aliasing right now with 4x, and that's going to be way cheaper than just doing ray tracing for the primary arrays. So it's like just not, these things are right now not in the same spheres of performance reasoning. When you have such a big hit from ray tracing, you don't trace primary arrays. So have I considered integrating DLSS? This is not an NVIDIA system, so I literally can't integrate DLSS. I have considered integrating FSR. I talked about this in the previous stream. I think there is a little bit of an issue philosophically about what the streams are. If the streams were about writing the production renderer, then I think you go FSR, XCSS, DLSS. NVIDIA has an NRD project, Neural Render Denoiser, something like that, I forget, which has implementations for a bunch of specific denoisers. However, I think the point of this is more about education and experimentation. And for that, I could integrate FSR on stream, but like it's just a freaking library with a bunch of shaders. You plug them in, it's a bunch of pain, but once you're through this pain, code magically works. And that also kind of feels bad, right? So I wanted to find a compromise where I do something that I can reasonably do on stream in a reasonable amount of time so that we can talk about trade-offs, talk about performance, explore like problems and stuff like this, but also get a reasonably good result. So right now I'm hoping that I can get there, but maybe, you know, 5 streams later when we start doing TAA, we'll be like, man, screw all this, let's do FSR. But I can't even do DLSS because it's not an NVIDIA GPU, so. Sorry, there is a comment right after this that says exactly what I just said. All right, so skeletal animations, yeah, maybe at some point in the future. Skeletal animations are funky because you have to rebuild BLASes, not just TLASes, which is going to be interesting. Do you need to add barriers for cache novelation? Yeah, so this is exactly what host coherent does. I think without host coherent, there is a special call called VK flush mapped memory ranges. Which you are supposed, and then there is another one called VK invalidate, which you are supposed to call after you change memory. And there is a provision in Vulkan that says that if you change memory but then do a submission, then that submission will see the memory without a flush. But I think this only holds if it's coherent. So there's like some language around what modes are correct when. The procedural description of what happens right now is that this memory is mapped in right combined fashion, and after every cache line, not cache line, there is a separate unit of granularity. It's often the cache line, it sometimes is not. After every cache line that the CPU fills in that memory, the cache line gets flushed right then and there to the device, and the amount of space that this cache this buffer holds is literally for 1, sometimes 4 or whatever. Like it's very, very small. It's not like an L1 or L2 or L3 size. It's like very small. And so practically speaking, I believe what happens is this combined transaction buffer just gets flushed like whenever you submit commands or something like this. Like it doesn't stay there for very long. But yeah, without host coherent, I believe, without host coherent, but also we are using persistent mapping, which means we map the buffer when we create it and then we never touch it again, which again is great because we don't have to pay the cost of mapping, which can be substantial, but it also does mean that you need to be a little bit more cognizant of these flushes and stuff like this. So I believe if you do persistent mapping, then coherent guarantees that you don't have to do anything else, as long as the memory isn't being used by the GPU like right now, as long as you have an extra submit there. Don't quote me on the exact semantics. And I think this behaves the same between device local and non-device local. I don't fully remember. The spec has a complete documentation for host coherent, which may disagree with some of what I said, but yeah. Anyway, okay, cool. So a huge success. We have an object that, well, not this. We have a scene that we loaded from GLTF where we can press spacebar and it animates this bike using my expertly crafted animation from Blender. What it doesn't do is it doesn't update the ray tracing buffers. And so because of this, you don't see these animation being reflected in the ray trace result. So we have to fix that. This was a few streams ago, but just to remind people, so we have this function called build TLAS, which is a top-level acceleration structure, where for every draw call, we don't have draw calls, but we call instances of objects draw calls. So for every draw call, we have an entry in that BLAS, and that entry specifies the transform matrix, which we compose from the quaternion that we have, the scale and translation. And it also has a bunch of other bits. It says if the object is opaque or not. It gives us the reference of the object that we can go back to when tracing array, which you can't see ever on the bike in this case, but this is why we have nice shadows here, is because whenever the ray hits from this pixel, the ray hits this object, we say, oh, this is the object number 47. We can go back to the data about this object with textures and transforms and vertices and whatnot, and fetch the vertices from the vertex buffer and stuff like this. We did all of this last time, I think, whenever we did transparent shadows. So, and then also this has the reference to the acceleration structure, which is a GPU pointer. And what we do is we create a buffer. When we load the scene, we create a buffer in CPU memory. We fill it on the CPU with all of this stuff. And then we have a bunch of welcome code, that is boring, to launch the build. So this builds the class from scratch. However, it essentially copied our transform data into some other tree-like data structure, into a bunch of different places in the tree-like data structure, which means that now that transform is static. And this is not something we can just patch in memory. This is not something that we can just go to memory and say, oh, just like, let's update this bit. This is something where we have to run this code again. Or rather, there's a more efficient way to do this, but we could also just run this code again. This code is not very fast. I mean, so it creates like buffers and stuff like this. And then also it creates classes and class buffer and whatever. But even if it didn't do all of this, it probably wouldn't be very fast. And the thing about this update, so I just spent a bunch of time talking about, oh, I don't want to copy the whole thing from CPU memory to GPU memory. It's going to be expensive. It's 48 megabytes. Well, there is no way, I believe, unless people correct me in chat, but I was briefly looking at the spec yesterday. There is no way to update one object, I believe, inside a TLAS. You have to update the whole thing. What does an update even do? We talked about this in the first ray tracing stream, but right now when we launch, when we run this code that like creates this acceleration structure, we pass it a mode and the mode is built. There's also a mode that says update. And if you look at the spec, the way update works is you have built the structure and now you want to update it with new information. So you run basically the same code as far as I remember. You have to tell it where to get the original data from. I forget if it's like, yeah. So inside this struct, there is like the source acceleration structure and destination. Destination is what you use when you build. When you update, you specify source, and I guess probably the same thing as a destination, I don't recall. This code then will be able to update the structure with the new information about the instances. There are some things you can't do. For example, there is this concept in acceleration structures called inactive objects. And this is actually what we are doing here. I forget when I added this, but we have objects in our scene right now that are not part of the acceleration structure, or rather they're marked as inactive. You can't even see them on screen right now, but like here, for example, inside this lamp, there is like a glass mesh like this. This glass mesh is translucent. We don't support translucency in the render right now, neither in raster nor in ray tracing. And so to avoid that thing casting shadows, I just like exclude it with this code. So you can't make an object active or inactive. You can't change the state like this, which is annoying because this means that to be able to hide or show the object dynamically, you'll have to like change the transform or something like this, which is weird, but whatever. But the other thing that we talked about is what does this do differently. So when you build the class, you build the tree from scratch and you get a tree-like structure in memory. When you update, what happens is a process called refitting, where every object that has changed position, you look at the node this object is in, you update the transform of that object, but you also update the bounding box of that node, and then you update all of the bounding boxes upstream of that. This means that if the object has moved far from its original position, updates become inefficient because they make your tree structure worse, or the tree sort of, the bounding boxes of the, like the topology of the tree stays constant, and so because of this, the structure of the tree gets less and less optimal the further you move objects from their initial position. So my understanding is the recommendations for all of this are usually that you kind of update the classes if you can, but then if you detect that the object has moved far enough, you just rebuild this from scratch. You could rebuild it from scratch every frame, which for a scene like this that has, as I said, like, so this has 3,000 draw calls, object instances. 3,000 is nothing. So for this, I'm sure we can do this every frame. There's not a fantastic way to precisely estimate how long this takes right now, because we run this code once and we create and destroy buffers and stuff like this. But this is like not free. However, so like for the scene of this complexity, it might be effectively free. Again, going back for the scene of this complexity, this will not be free. And I don't want to lose time on this too much. On this update too much. So having said this, we currently don't have a mode where animations work at the same time as having a high object count. So in the spirit of not creating problems, not solving problems that we don't have yet, here's I think what I'm gonna do. So I think I want to have the update code. And then I'll just run the update code every frame if animation is enabled or something like this. Like if the objects have moved basically, which in every real game is basically every frame. But this will make sure we don't randomly regress performance on this giant multi-kitten scene, and then we'll think about that at some point in the future. But let's talk about what needs to happen to even do this update. So I'm a little bit fuzzy on this because, like, I mean, I haven't done this. I briefly looked at the spec. I'm going to enable all possible validations to make sure I don't break something catastrophically. Okay. So, one option would be we can just run this code again. But if we run this code again, things are going to be slow. I guess there's an intermediate option, which is we can run some of this code again. Let me think about this for a second. Because what I kind of want to do is I kind of want to move this code to GPU. And this layout is fixed anyway. But maybe that's just too much work right now. Oh, we are like 2 hours in almost. Because one option is to run this code. One option is to move this code to GPU and then just run this update code like somewhere. This is basically GPU setup because it's a buffer. I will cache this, but then to pass this data to the GPU. Oh, I can't update BLAS addresses anyway, right? because, well, you can't make an object inactive. I guess you can technically update. The other thing we haven't talked about, which we don't do at the time, or like right now, but in the future we'll need to do level of detail integration. Right now there can be sometimes bugs in the shadows because the level of detail for ray tracing is always 0. So when it doesn't match the visual, with the rasterized level of detail, you see self-occlusion on objects sometimes. To do that, we'll have to update the BLAS. Again, not a problem we have right now, but... So what do I want to do? And like, this is a bunch of weird code, obviously, so... But I'll need to keep the scratch buffer around. I'll need to keep this one around anyway. Okay, let's tactically refactor this code a little bit first, because I want to split the buffer creation of this from the rest, because we will need to keep the buffers around for anything to happen performantly. One thing we are ignoring is when you ask the driver, what do you want to, I want to build this structure, how much memory do I need? We were using these two sizes. This is the size that the structures will take in memory forever. And this is a temporary buffer that you only need while you're creating them. But there's also this other size, which is how much space do you need for updates. So actually, let's do this first. Because I'm pretty sure I want to have access to updates. No, not the mode, hold on. So when you create this, wait. Oh, interesting. So here you say allow update. So it's like I want to build this, but I want to allow update. It's kind of weird. API slightly because... Okay, so let's enable updates and let's actually look at the size that this update scratch thing to the driver tells us is. Because I'm just wondering what it is. And if it's not too large, which it shouldn't be, but just in case. Oh, you can't see this because it's maybe hidden. So this is our acceleration structure. So it's telling us essentially, okay, to create this structure, you need 0.5 MB of memory, of temporary memory. And then if you ever need to update it, we just need like 20 kilobytes of memory or whatever. We don't have that many objects, so let's look at what these sizes are on this. So when you have 1 million objects, the costs are steep. You need 200 megabytes for the structure, 180 to build it, so that's temporary, and then 8 to update it. So if you only ever update it, then your persistent memory cost is 230 plus 8. But if you ever need to rebuild it, it's 230 plus 180, because you need like a buffer for this. Yeah. Is it realistic to only ever update? It just feels like no. If an object moves, so the issue with refitting is this. I think we'll need, it doesn't matter that much, we are eating a bunch of memory elsewhere, but so like right now, if you imagine bounding boxes around this bike, essentially what I'm saying is refitting kind of degrades these bounding boxes to accommodate all past and future motions of this bike over time. Because every time it looks at the tree and it's like, oh, how far should we push it? It's not quite like this, because refitting can also, it's not quite a precise description, but that's one way to think about this. But if you looked in some other portion of the scene, like here, then if this bike traveled from here to there. Unfortunately, I don't know if the driver can only enlarge the boxes or if it refits them based on the contents. It's still gonna be bad though, because yeah. So this stuff is hard to make decisions around without like an actual scene. Because you don't know how costly these things are gonna be. And also for our scene, 0.5 MB to update, to 0.5 MB for an option to rebuild the whole thing from scratch at any point is completely fine. 200 MB is not a small number. And also we will need to keep this object around in memory, by the way. Yeah, because this is the only way to update. We can't point the driver to our draw call structure and tell it this is where you get to transform from. We have to make a new one. The structure is it's probably 64 bytes. So it has 48 bytes of transforms and then 16 bytes of extra stuff. So this is 64 bytes. This is larger than our draw structure. And so for a million objects, this is also 65 megs, 64 megs. Okay. But this is non-negotiable because even in the update path, we need this. These crash space requirements are not small. Wow. For like a million objects. And this is super not small. So this is essentially saying the driver needs 180 bytes of this is for builds. Yeah, okay, I'm coming back to this. Refitting is cheap. Builds are expensive. Okay. And then the instances thing, it's actually currently inside a device local, or inside a host visible buffer that's not mapped, that's not a device buffer. Because I didn't have, this code was written to run once. And now we are potentially running some of this code, parts of this code per frame. Okay. It's kind of premature optimization, but also it kind of matters how you structure the code before you start writing the code. But we can just write it however and then rewrite it later. So maybe let's do this. Maybe let's just write it however, and then we will rewrite it later. So then to update, we will need the buffers will already be allocated. So because all of this stuff is kind of tricky, I think I want to do this in the simplest possible way. And then, because there's no way for us to test performance in a scene with many objects other than just running this code. The fact that this is host visible is not gonna work. The fact that this is not device memory, or rather, can I do device memory? Like, there's no reason not to expect this to work, right? No, wait, memory, property, device local. So if this object, which I'll need anyway, is device local memory, All right, so let's just pull this code apart a little bit because we are going to need to do this anyway. So this stuff is not even used after this. Okay, so let's just do this one step at a time. So first of all, we'll need to keep the BLAS addresses. Basically, I want to extract every part of this code that I will need to be able to run an update. And then maybe write a function that just does an update, and then we'll see how things work. So key device address BLAS addresses, or actually just don't need this, it's fine. So then I want to create this buffer for instances once and then fill this. Let me move this guy to a function because I don't want to copy that. Fill RT instance or fill instance RT. So this guy will essentially say, given a draw call, please fill. I was thinking maybe I was initially thinking I will move this to GPU, to compute trade or whatever, but we don't have that much time. Oh my god, hold on. All right, today this feature that they added with completion is bad, man. This is what happens when people blindly take ideas from Cursor and like just don't think about the consequences. This is bad. So I was thinking I will move this code to compute, but to save time today, we are just gonna update stuff on CPU the same way that we patched animation data. And then I'll think about this at some point. I don't know, under the Christmas tree. Acceleration structure instance. So this is just a straightforward fill instance RT instance draw index BLAS, except that to disable this, oh no, yeah, this code is here, cool. And then memcpy. And now I can move the buffer creation outside as well, because I will need this buffer here. So I guess we'll call this like instance RT buffer. And then we will pass this buffer I guess we might as well fill this here then, because this code is straightforward. Oh, this is BLAS addresses. Okay, so then instance RT buffer, there should be a better name for this, but whatever, that's fine for now. So now that has all of the information that we need ever. So instead of I'm sure we use a count of draw calls somewhere. Yeah. So instead of this, we are going to pass instance buffer. Okay, that's fine. And then we will pass like a draw call count. We'll just call it primitive count because we already have this here. So this is that. Is there no device address here? There's not. Should add it in the future. Okay, and then this used to create the buffer. Now we don't need that. And then I will need this crash buffer to run the update. I am tempted. So what I'm gonna do, this is not the most efficient way if you never want to rebuild, but I'm just skeptical that I never want to rebuild, because there is just going to be cases, I'm sure, where we will need to rebuild the RT buffer from scratch, sort of. And so what I'm gonna do is I'm gonna just create one crash buffer and just keep it around. And then when I'm creating this buffer, I'm gonna take the maximum of the build crash and updates crash, and that way I should be able to use this buffer for kind of either purpose, whatever I decide to do there. Okay, so I'm gradually refactoring this function to be able to call something like this during the frame, even if it's not exactly like this. So let's see if this works. I need to destroy these two buffers that I have created. But I think if this works, we'll be able to run almost the exact same code during the frame. And we will be able to reuse the buffers and just call an update. And then we'll see how long the update takes. Maybe we'll see how long the build takes and stuff like this. And then we'll be able to like actually work with this. I kind of low-key hate the names that I've just randomly come up with, but we'll keep the names as is. I'll rename things later. So now, if you think about what build class does, is it creates a bunch of buffers, and then it fills a bunch of val constructors that are kind of straightforward, and then it does this special thing which we do sometimes, where it runs the command buffer and then immediately submits it and waits for it to happen, just for simplicity, sort of. But a lot of this code is the code for creation of buffers. Obviously, like we would need. Actually, with this, I can just mark the first frame. I don't even need to do this here now, almost, because the only reason why I'm doing this in a separate. I just did this for expediency. I super don't need to be doing this. What I should be doing now is this. On the first frame, we don't have a valid. If we remove the actual build code from here, which we should, on the first frame we will not have valid class data, but we can just run this in our command buffer before everything else, and then we can place a barrier there to make sure that that build is done before we start using this, and that's it. And so instead of build class, this function is now called create class. I think we'll have to duplicate a little bit of this code. to run the update, but let's split it essentially into create and update/build. So creation finishes here. We have created a bunch of buffers that will hold the data in the future. We have created the actual object, the acceleration structure. The object hasn't been built yet. And this is what this code is for. And that is where we will end this function. So that is going to be in the create class. And then we are going to have a separate function called update+, which instead of waiting, submitting, it's just gonna add a command to the command buffer that will do the build or the update. So we don't need the command pool for this. We just need the command buffer. We want a mode, like what are we actually doing? And then we'll want to copy some of this code, but this code is so simple that I'm just going to copy it now. Or I guess it could say build+, it's fine. It'll just have a mode build class, sorry. So let's see, we'll need most of this code actually, but that's okay. So when we run the build process, this is the same code we used to have. We pass it the instance buffer. This function is hopefully very cheap to just call every frame. I might cache it later in the future. So then we have the scratch, and then we don't even need this last buffer, but we need the actual object, vk acceleration structure keychar class. So you get the device. Why do you even need? I guess you currently need the device. Let's actually pass command buffer first, or at least second, because that matches the Vulkan conventions for command recording functions better. And then we will pass the mode here. Whatever the type of this enum is. Oh, wait, autocomplete is that. Okay, vk acceleration structure build mode, I'm sure something like this build type. Okay, so this is the mode. Structure mode, build mode. Oh my god, what is the mode? vk build acceleration structure mode. Okay. That is not the order of the words that I expected here. So build range, blah, 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 and then you delete all of this. So that is it. So essentially through very mechanical changes, we have split this function. Now we can call this function. We have to call this function at least once. So we will have a boolean here that says class needs rebuild, and we will start this as true. And then on the first frame, we will call this for sure. And then on subsequent frames, we can call it in update mode, but only if animation is going or something like this. So let's do that. Wherever we have, let's see. So we have query timestamp. The frame has started here. This is similar to some other kind of clear like preparation code that we have there. So let's just do this here for now. So if ray tracing is supported, so if TLAS needs rebuild, then we have to call this function. So device, command buffer, TLAS. So this is our scratch buffer, and we sized it so that we can use it for builds or updates. This is our TLAS instance RT buffer. God, why did I call it? This is the name that I actually hate. I'm gonna change it to TLAS instance buffer. Okay, so draw size, and then the mode is vk build acceleration acceleration structure build. Oh my god. VK build acceleration structure mode build. Yes, perfect. Okay, and then that's actually it. And then we'll add update code later. And then here we need create class, and then we for create class we no longer need command buffer, command pool, queue. This function is much more pure now. It just creates resources and allocates resources. So I think this is it. Okay, so this should work exactly as our code used to work. Oh, I forgot a barrier. Oh, and I forget. No, wait, hold on. All right, hold on. So you should return. B, did I believe it print? Oh, no, this just went in a cycle. Okay, cool. This is why you probably should be using warnings as errors, but I didn't. Okay, so this works exactly as our code used to work. We just split build into create and build, but now create doesn't submit commands and build doesn't synchronize anything, and so we can just reuse build here. There's not really a thing here. All right, that's fine. So if we need a rebuild, then we need a rebuild. Just out of curiosity, what we should be able to do now is we can just say if class needs rebuild or animation enabled, then we'll just build the class from scratch every time. In theory, this should work. And this will by itself do nothing, assuming it works. We need a barrier. I should just put a barrier. Because I'm not actually changing the transforms. But now this build should actually work and like do something every frame. And so in theory now, if we go all the way back to the animation code, or all the way here to the animation code, and say, well, if ray tracing is supported, then we have this other thing that we need to do, which is we have the instance that we need to fill. We're going to fill it from scratch using the same stuff, and then we're going to memcpy it. And again, the exact same considerations apply. In theory, we are only updating the transform matrix, but I'm like squeamish about what will happen exactly if I only update the transform matrix. And with this code, well, I wouldn't use it for LOD because that would have to happen on a GPU, but yeah. Let's just try this and see what happens, because maybe it works, and then we'll talk about performance implications. All right. Okay. So I'm still missing a barrier. Validation layers are enabled but silent on this. That is not cool. That is a missing validation thing in validation layers. So let me actually. So I need to do two things. One is GLTF validation should. Can I do it today? Okay, it should fail for. Why does it complete in? So weird. All right, so it should fail for basically mismatching component types for rotation, scale, etc. Like you shouldn't be able to have rotation that's like a vector 3 or whatever. And then the second thing is Vulkan validation layers. Missing sync validation for build, presumably build/update of class and subsequent use. So I'm gonna do this after the stream, assuming this file doesn't disappear into ether. But what is missing right now is that we are doing some operations on the class, that like updates it. But this process is a bunch of compute shaders that happen, that end who knows when. And after this, at some point, we are going to use that to like actually run the ray tracing code. And so what should happen is there should be a pipeline barrier, and we actually have a pipeline barrier like this in blast building code, because blast building code has a somewhat similar concern, because it does a bunch of builds in parallel and then it wants to reuse the scratch space, so it needs to wait for them to finish and stuff like this. So it has this barrier that we kind of, well, it's not the same barrier, but yeah, we could just place it here. We're not quite sure what will happen though with this data. Yeah, I'm just gonna place this here. Technically, you need this barrier even on the scratch buffer. So technically, you need two barriers, I think. One barrier says we have a scratch buffer. We have built an acceleration structure with it, but we might build it again, if that makes sense. Oh, and there's an instance buffer. So technically, there's a bunch of barriers that you need on this. I think you need a barrier for every buffer. There's 3 buffers involved. There's the scratch buffer, the instance buffer, and the actual TLAS buffer. I think you need a barrier on all 3. But like, yeah. So don't quote me on this. Let's just write code that I think is correct. I don't actually know if it is. I need to read the spec for this. But what I think you should do, what seems like the right thing to do, is there's 3 buffers involved in the operation: TLAS, scratch, and instance. Scratch and instance are straightforward. They're only used in the build process. So we have just used them to build stuff. And like, I guess you need a buffer. You need like another barrier. I'm not going to put a barrier in front. There's maybe a barrier in front that you need as well, but that's kind of overboard. But I think otherwise, so scratch and instance, there's a write after write hazard, which only happens if you update the thing twice per frame. Okay, you know what? This is stupid. Let me just put one barrier here. Technically, I think you need 3, but this is getting ridiculous. So I think 1 is enough, practically speaking, because I just can't imagine. But then you kind of need a barrier on the other end. Let's just put 1 barrier so that I feel safe, and then the actual problem is the validation synchronization doesn't complain. And so when it starts complaining, I'll fix this. So I think this is kind of what should happen. Like, we were using the acceleration structure build stage to write to the structure, but then we are going to use compute to read from the structure. I don't feel comfortable writing correct barrier code without having correct synchronization validation, which is why I am upset that it doesn't work. So notice we still aren't doing updates. We are still doing a full rebuild. To do an update, you have to specify, I wonder if you can just always specify both source and destination, and then based on the mode, it will figure out what to do. But in theory now, what we can do is we can say, well, if it needs a rebuild, then do a rebuild. Otherwise, if there's an animation enabled, then do an update. And this should mean that now every frame there is less work being done. Not that there is a lot of work being done right now, because there is only so many objects. And again, the total GPU frame time, we don't have a separate marker for this. We should probably add it, maybe. But that's painful, so I will not do this right now. But the total GPU time doesn't like change when I pause and unpause animation, and this is what should stop or resume the TLAS updates every frame. Like, we don't actually check if we have any animations playing. So like here you don't see any change. However, the real test is this. This is a, oh, I forgot to, ha. Of course, I'm doing a build, so I forgot to set the flag to false. I didn't even notice this. So maybe updates don't work. But look at the GPU time. It's like 17 milliseconds. So now let's see what I meant to do is clear this flag once the rebuild is done. So now it's 3. So we know on this scene it takes 14 milliseconds to do a full TLAS build. That's insane, right? This means I don't really know what this means. This means ray tracing is not useful, I guess. I don't know. So what some like, it's just too long, right? Like, you can't spend 14 milliseconds a frame. That's insane. That's like way more than our frame budget. Did I do the, yeah, I did do the device level thing. So obviously there's an option of only ever using the updates to update the object's motion. Let's look at what that costs. So this is 3.9. This is 5.5. Even just an update takes forever. This is 1.6 milliseconds on TLAS update. That is insanity. Obviously here we can just check, oh, we don't have any animations playing, we just can skip it. So this is making me question two things. One is I know some games have two classes, one for static objects, one for dynamic objects, because that way you can only update the dynamic one. The other thing that's making me question, the other thing that this is making me question is there really no way to do a partial update, given that the updates are so freaking expensive? Maybe the chat already has answers to some of these, but let's check that the updates actually work, because now we don't actually do a rebuild every frame. Oh, okay, it was actually costing us a significant amount of time. I was wondering about this. The last build is reasonably fast. Okay, I want a marker on this. I want a performance measurement on this, because this is expensive stuff, like really expensive stuff. The only problem is all right, I should have I should have fixed this already. At some point we'll write, or maybe I'll write off stream, we'll see. We need like an actual freaking GPU profiler, in the sense that I'm doing manual management of timestamp indices in the pool, and that clearly is becoming too painful. In the spirit of not solving problems we don't have, we haven't felt the need to write an actual timestamp utility helper, but now we need it. Okay, so this is 16, 17, 18, 19, so 20 is free. So this is going to be 20 and 21. These will have the timestamps, and then whenever we get the query, which happens after, I guess. So this guy now has 22 results it needs to collect. And now we have class time. which is either build or update, but we'll only see the update. Okay, so even for our scene, actually, the update or the full build is very slow comparatively, and the update is better, but still bad. Okay. I guess I'll just add this here for now. So let's look at this. Oh. One moment. Yeah. I have like a terminal thing that truncates. Is it really 112? Or do I have a bug? Must be 112. Okay, this is too many timings anyway. So let's just shift things. So right now it's taking 0 milliseconds to update TLAS, which makes sense because there is nothing to update. But once we start the animation, it's now 40 microseconds or whatever. So that's like very reasonable, right? That's not a problem at all on this scene. However, if we now change our code back to, for example, let's say we forget this Boolean thing. Now it takes 0.75 milliseconds to rebuild TLAS from scratch. That is not insignificant. Essentially, this means we not only can we not afford to do this every frame. If there is frames where we must do this, these frames will be longer, like noticeably longer. 0.75 milliseconds is not nothing. Did I mess up some? It just feels there's 3,000 objects. I understand the kitten scene, but there's 3,000 objects. What the heck is it doing there for so long? Interesting. I will measure RADV driver in a moment. So, but one thing I'm wondering is, did I like mess up some memory location on some of this stuff? Because it's just slow. All of this stuff is in local, it's not even host visible. The instances I put in local. I'm very sure this will not impact the performance of the build. Wow. Maybe that's what it is, but that's really slow. Let's use RADV driver and see how performance is there. Same ballpark, 0.75, this 0.80, same ballpark, interesting. Huh. Unexpected. I thought full rebuilds are not that slow on 3,000 objects. This is nothing. Yeah. Okay. Let me rename this because I hate the name. And then I'll fix the Boolean back. So much scrolling. Should start breaking this into files maybe. Yeah, interesting. Let's see. Let's check that the code works. Oh, I have validate. Let me remeasure this without validation. Maybe my comments are unfair. Oh, on RADV, even just the update is slow. Wait, it doesn't work? Did I mess up the scene again? I messed up the scene, sorry. So the code works on RADV. Even the update is slow on RADV because it's the same 0.7 milliseconds roughly. So RADV just will not work performance-wise. That is just unsustainable, people. Interesting. Interesting. Okay. As I said before, I have given up on RADV for ray tracing for foreseeable future. They have a lot of work to do on performance. Like literally their TLAS update, RADV's TLAS update is like 15 times slower. What is it? The update on the AMD driver is completely fine. 40 microseconds, it has to patch a bunch of stuff. It's like 3,000 objects, there's some inefficiencies, whatever. The update I'm completely fine with, this is okay. I'm surprised the build cost is this steep on both, and I'm surprised the update cost is this steep on RADV. All right, so let me look at chat, but before this, I wanna split, since I had to split these anyhow, let me split them slightly differently. I'm gonna split them into like a ray tracing, rasterization and ray tracing work logically. Obviously, we can change this, however, in the future. So this is where this will go, like this. Okay, like this. And just to make things easier to read, so that there is one line for all raster timings, there's one line for all ray tracing specific timings. Final pass is technically always necessary. I mean, the good news is all of these timings shouldn't depend on the resolution. The bad news is all of these timings are, well, the update is completely fine on this small scene. Again, if we were to, obviously when we render this stuff, we don't need to run an update if the animation is enabled because there's nothing to animate. But I think it's actually helpful to keep the code in this state because it gives us a sense, what is the performance cost of having every single kitten right now rotate? Turns out it's pretty steep. Turns out it's pretty steep. If you can't deactivate instances, I guess people rebuild from visible objects and expand the frustum. All of this is terrible. We have just created a whole lot of future problems for ourselves by implementing dynamic like transforms, I guess, for objects. Let's check again without validation. No, it's the exact same cost. That's kind of what it should be expected because we aren't doing GPU-based validation. Whoa, oh, sorry, hold on, do it again. The GPU times should be the same because we are not doing GPU-based validation. There should not be an overhead on the GPU side that the validation layer is introduced, which there isn't. It's the same timings. Okay. So the good news is we are back to the correct rendering with animations. And we don't have performance problems on this scene. I'm just like anticipating future problems with many objects that move at the same time and TLAS takes forever to update and things are bad and stuff like this. All right. Okay. Okay. So let me commit this and then I'll look at chat. Yeah. Fine. Update. We can print separately, that part's fine. And then source dest, and then remove a bunch of this stuff. Needs rebuild. And then that, And then the timings. I think this is all correct. Implement TLAS. I mean, I'm glad we've gone through all of this, because I guess the question of can we afford to build every frame that I had when I started to talk about this is resolved. We can't, even on our scene, even on our small scene. Insanity. This implements correct class update. Using same code as build, we retain the property, or we retain the ability to rebuild class at any point. However, we really shouldn't, as the cost is steep. It's like a weird trade-off because the more objects move, the more you start losing time on ray traces because your trees become less optimal. But like 0.75 milliseconds for 3000 objects is a lot. Okay, let's see what has happened in chat since I last looked. Yeah, like, so there is an NVIDIA ray tracing best practices that recommends rebuilding class every frame. So maybe the NVIDIA driver is drastically different. So notice on both drivers, the cost of the build is roughly the same as 0.8 milliseconds. On RADV, in addition to this, they don't have a fast path for updates. At least on the official MD driver, they do. But so maybe on NVIDIA, things are way better for class builds. I don't... this system doesn't have an NVIDIA GPU for me to test, so I don't know. But certainly updates are completely fine, but builds just on this scene would not be fine on this. And maybe, you know, maybe AMD just does something terrible in their class builds, I'm not sure. But that's like not great. So yeah, the problem you need to do a refit probably. You need to do an update for LODs because right now the LODs in the ray tracing structure are incorrect. I have been delaying doing this for two reasons. One is we didn't have an update path, now we do. But the other one is we don't even build blasses for level of detail, and doing that would increase our blast size dramatically, probably like 2-3x, just because it's way more data, it's way more triangles. So I have been avoiding doing that. You can see some bugs. It's not super visible. Let me see if I can try to spot some. It's easier to see in this mode where there's no blurring. Yeah, so if you look at this part of the wall, see it's in shadow right now and it's not right now. Now, if I disable shadows, you can't really see a lot transition there. Like the visual, nothing changes. Even if I enabled normals, there's no way for me to disable just shadows right now without everything else, but like there's not, it's a smooth lot transition. But it collapses the triangles just enough for the new triangle to be slightly offset from the wall. And because the ray tracing is based around the original geometry, the ray starts a little bit inside the wall, and you see like this bug, right? If I completely disable level of detail, which I've just done, this problem gets fixed because the raster view is also using LAD0. So that's like a problem. Fixing that problem requires twice as much memory for blasses. I don't want to fix this problem yet because of this, but I will have to. It's probably not an option realistically to not do this. But yeah, this is there's some things we can try to do to offset this. For example, one thing I think I can try is when we generate LODs, we get a number, which is how far the new LOD is from the previous LOD. And maybe for ray tracing, we don't have to have redundant LODs if they are too close to each other in geometry space. So maybe that will reduce the cost of doing things like this. But this is like non-trivial, right? So you see how there's a lot of stuff that in rasterization is just free, almost. In shadow maps, you can just render the same LOD. There is an issue with shadow maps that's kind of similar, which is if you cache shadow maps across frames and your LOD transition happens, you can have the same disocclusion. But your cost is just frame time, not like memory to fix this. Anyway, Not sure what problem you're facing with GLTF viewer. Not sure which GLTF viewer. Quantum harmonizer. What? Merging all static meshes is supposedly best for performance. We actually tried this a little bit. We tried this once, but this was on the RADV driver, so I don't know if this is true. And in theory, there's some optimizations in the driver that seem to be off right now that may make this less necessary. But yeah, that's a recommendation that definitely AMD themselves said at some point in the past, which would reduce the problem, right? Because you would have a simpler class, but it would also mean you can't move some objects. But again, 3,000 objects is nothing. So the fact that this is a problem, yes, so that is a good comment. That is an excellent comment. In theory, maybe actually, let's do this. Oh, that will not quite work. So let me enable animations by default. Did I commit all of this? Yeah, okay. So we can actually look at the RGB trace. This is not, there's no way for me to gather a trace from the official driver. Their driver interaction with GPU profiler is broken on Linux in the official drivers. But in the unofficial drivers it works, which is completely different driver. So, you know, is it the wrong scene again? It is the wrong scene again. Oh my God. I guess it shouldn't matter, but we do see the bike rocking now. Okay. In theory, I can skip this work if the scene doesn't have animations, but I actually like the property of the code performance being less dependent on the scene for now. We'll see if I keep liking it. Radeon. So oh boy. Well, at least the RADV driver adds debug markers, so you can see the costs. Man, I'm just surprised it's this slow, honestly. What is it doing? The efficiency is commendable. So yeah, so there is a comment that is very correct and very true, which is that you should be able to, so this is the pass that does ray tracing. Again, so like on RADV driver, it is much slower than it is on AMD driver for some other reasons we talked about in the previous streams. But this stuff is rasterization. This stuff is rasterization that only writes to gbuffer. It doesn't actually need access to ray tracing. So in theory, what you can do indeed is you can take this code and run it in parallel with this. The reason why this doesn't happen right now is kind of twofold. One is we put a barrier, and even though we put a barrier against compute work, and the way these barriers usually work on desktop architectures is like it stops raster work as well, I think, if I'm not mistaken. But even if this was not the case, I mean, there might even be compute dispatches that we do. Yeah, of course, right. We put a barrier, let me rephrase this. We put a barrier saying on this buffer, we would like to synchronize between acceleration and compute. But what happens is usually the drivers don't have this granularity of synchronization available to them. At best, what they do is stage-based synchronization, which means any compute dispatch after this would block further progress. And there is a compute dispatch right after this, which is this. But there is so many other things. I don't want to go into the details, but there's so many other things that make this perfect world where we just say wait for compute to be suboptimal, that the only practical way to do this in parallel would be to have a separate queue where this stuff executes and then synchronize between these two queues. Obviously, and then what you will have is you will have some overlap between them. You might slow this down because there is other work happening on the GPU at the same time, and you might slow this down because there is other work happening at the same time, but usually the end result is going to be much faster. Now, obviously, the problem right now is this is just too long by itself. So like even in perfect parallelism, this is like 726. I think I mentioned that RADV is like faster, surprisingly so here at this, at the gbuffer fill. No, maybe, oh no, this was a small window, never mind, this is all good. So on this small window, this would be the overlap in the perfect world, so you'd still delay substantially the ray tracing. Now in 4K, gbuffer pass took closer to a millisecond, so the overlap would work out to be much better. Obviously on the kitten scene or whatever, like this would not work. But that's a good thing actually, because we might do this at some point. Interestingly, so somebody just asked in the beginning of the stream, can you do ray tracing effectively for primary rays? The only reason why this comment can even work, the comment about the overlap, is we don't use ray tracing in the first half of the frame. If you start using ray tracing everywhere, these costs are now non-hideable, so that's cool. But yeah, this is the RADV driver, which has very inefficient updates. So this is not even the performance problem that we have on the official driver, if that makes sense, because right now, even if we update every frame, the update cost is very small. The build cost, though, is not very small. So yeah, anyway, maybe at some point we'll do the overlap thing. The overlap thing is 2 queues and some weird cross queue barriers, but it's not too bad usually. But for now, we don't need to, because for now there is not a practical reason for us to want to rebuild every frame. So again, and I know this is an update, but this driver is just bad. So well, this driver is very good, but the performance of ray tracing on this driver is not where it needs to be at all. I'm wondering if I'm like missing something, because this problem I did not expect. Why does it? I have RADV source code. Let's just look at the RADV source code and ask, does it even, what does it change when you say I only want to update? Build mode. I forget what the constant is. It's actually very surprising, because I feel like maybe there's a bug in the code or something, in some code, because it doesn't even have the scratch space to do. There should be an update. Unfortunately, I don't think there's a way for us to check in the profile. this clearly just does like, this is like a rebuild. plog is like an algorithm to rebuild the whole thing. Does it have heuristics or something when it switches between the modes? Or did I... This is the code that gets executed. Oh no, this might be the code that gets... Oh, interesting. Interesting, so it's the same code flow. Huh. I'm honestly surprised. All right. I don't quite know what to make of this. I'll file a bug, I guess, in Mesa. I'm worried there might be a thing where the update is slow, but the benchmarks they tested on, like, have enough overhead in the actual ray tracing that any amount of time you spend on updates makes up for it. But that's a decision that should be up to the application, not... so again, on RADV right now, I don't want to spend 0.75 milliseconds doing all of this. There's no world in which this is realistic. In fact, we can check on the official driver if there is any change in ray tracing performance based on whether we rebuild or update every frame. Like the actual raycasts, do they get slower or not? But because it's just an object in a small segment of the scene, it shouldn't be that bad, I would think. Anyway, unless I just have a bug where I forgot to specify some mode and validation layers are not... the one thing, I guess, the one thing we can... Oh, no, stop. Okay. The one thing we can do, of course, is we can ask for a faster build. When we build the TLAS, we say, oh, we'd like the fastest race. Flags are duplicated, which is annoying. Do I even need this bit here? CPI is a little funky now. Because, like, if I update... Should I say that I need to update? Should I say that I need to allow updates if I'm already updating? But okay, so the one thing is during update, maybe this is the problem actually. Let's see. Maybe I'm too harsh on RADV. Let me kill all of this stuff. We are kind of asking for a weird thing. Well, I can't do it like this. One moment. We are kind of asking for a weird thing. We are saying, can you update the structure, but at the same time prefer maximum possible ray tracing performance? It is possible that the two drivers interpret that request differently. It is possible that the RADV driver says, oh, you want fast traces, we're gonna like build it for real. And the ME driver is like, yeah, you said you want fast traces, but you asked for an update, so we'll just update. So let's see what happens. Nah, nope. Wait. Oh yeah, I enabled animation by default for the sake of profiling. So that doesn't change a thing. Let me add a printf just so that I'm not like deluding myself into thinking I'm doing the right thing here, and just to validate. I could read RAD source code closely. I don't want to do this right now. No, yeah, we are doing updates. I don't know. These flags are counterintuitive in this context to begin with, I should say. Because it's like you have to specify them when you kind of weird. But no, so this is for the build. And this is for the structure. So I think the correct usage of this API, but I need to really double check performance. Let's do this with the MD driver. But I think I'm over specifying the flags because this API is kind of dual. These structures are dual use. Wait, didn't I remove the print? What? Oh, I didn't save the file. Okay, all good. The structures are dual use. You use them to ask how much memory you need for a structure, and then you use them to actually do the build. So that's a little iffy. Let's just double check. So right now the performance is 1.8 on the official driver, the total frame performance, 1.22 for shadows. So I think what you should be doing is when you create it, you only say, I want the structure to allow updating. And the mode shouldn't even matter. I guess build is 0, but like you aren't building anything, you're just asking how much memory you'll need. And then when you actually run the code, you don't need an allow update bit. You already said you want to allow updates. So I think this is how this should work. I'll need to double check the validation, but I also want to double check performance. Oh no. All right. That is what I get for running without validation. That is a good way to end the stream. What the heck? Oh well. I'm not sure I can terminate this now. I'm not sure how to terminate this now. Let me think about this. Interesting. Oh. Okay. Where are we? Indeed, that is not how you are supposed to do that. I'm not sure why the stream is still buffering. So clearly it works. Is the frame time bad? Let me just double check. So we just dropped like 1,000 frames, so that's cool. The upload bandwidth is back. YouTube still thinks that the video is poor. I'm not sure why. I think this happened before. Okay, so I forgot to give the disclaimer at the beginning of the stream, and that is what I get for forgetting to do that. What we have just experienced is I had validation layers disabled, and I ran the code that clearly was not correct. So my editor is like in a really weird state now. Let me just restart that. So, okay, stream looks fine. YouTube, I had this weird issue with the indicator before. Yeah, so I thought the flags looked sus, so I fixed them. But what actually has happened is, I guess it breaks, like it breaks some contract in API. I had validation layers disabled, etc., etc. So let us not do that. I will like later fix this. It's been 3 hours in anyway. Let me just like one final thing I wanted to try. Oh no, but I already tried this, right? I already tried fast build. That it was the same. No, maybe not. Let me just try this again, because maybe the issue is the mismatch actually. Maybe once you create the structure with one set of flags, you can never use it again with a different set of flags, because it's the thing that determines the format of the BVH. But I don't understand the language there, because it says the given acceleration structure build should prioritize. Not that the structure should prioritize, the build should prioritize. But ostensibly it would make sense that the type of the build that you do determines the format. And so of course changing this between builds and updates would break stuff. So let's do fast build. But what will fast build even accomplish? What I've been trying to... I guess this doesn't really matter then, because... I mean, we can check what fast build will do, hopefully without killing the stream. And this time I will enable validation. To see if I have bugs before the code kills the GPU. No, yeah, okay, this is fine. Yeah, so doing this, so switching to fast build for TLAS drops the performance a little bit. The update is still the same, roughly speaking. Let's see what happens when you build every frame. So like if I don't ever set this guy to false. Point 15. So the build in the fast build mode on the official driver is fast. This is like close to, you can just run it every frame, especially if you overlap it with the raster work, there is no problem. The build that is kind of slow is the build in the fast trace mode. But then of course the problem is you lose performance during traces because, so again, if I run this is not 4K, but like, I guess we can like, let's look at the, if we run 4K, the shadow traces cost 4.45 right now. And then if I disable the fast build mode, then they cost 3.6. So you're losing 0.8 milliseconds on your traces, but you're gaining, if you're doing build every frame, you're gaining 0.6 or whatever, so that's not economical in 4K. All right, so all of this is like the land of terrible trade-offs. There is literally no right answer here other than don't use RADV, because RADV updates are slow for some reason, and never rebuild TLAS, because rebuilding TLAS is slow for some reason. Okay, that's cool. So in the future, I don't want to do it today. It's already been 3 hours. In the future, we are probably going to do an overlap on the second queue. That might be good because we haven't done 2 queues at all. In fact, I think I haven't done 2 queues. I can't recall. I mean, I must have tested this at some point for uploads, but I don't think I shipped anything with 2 queues. And that's for sure. So we'll probably have to do this at some point. But okay, the final thing is the thing I promised to show at the beginning of the stream, which is the checkerboard stuff and how it interacts with the temporal things. I need to do a little bit of code surgery on this because right now I have 2 buffers. I do checkerboard in one and then I blur between that one and the next one. We did this last stream without the checkerboarding. And for the temporal thing to work, I have to have 2 frames. I have to have 2 frames to fill the same buffer, which means I can't blur into it. So what I have to do is I have to create 2 targets. I'll just like very quickly hack this together. I will not commit this code. It's just to show you guys what I think we will see, which is we will see ghosting. And then, so from, and then 2 is this, and then here, some barriers, I guess, have to change. Okay. And then wait, what? Where do I? Oh, I already added this. Oh, okay. Oh, I didn't add it here. I got it. Okay, that makes more sense. So this just is me splitting the targets, like that doesn't matter. Let me make sure I keep validation layers on because I want to avoid future surprises. So this doesn't do the thing that I was saying we will need. Oh, right. Yeah. Hold on. Okay, so right now this is still the same code. I just have a separate target so that things don't get broken. So right now, this is the indicator for shadow checkerboarding. So I can like disable and enable this. So when you enable it, we have the aliasing issues. What we don't have is we don't have ghosting because when you go back and forth. So like every frame right now, half of the pixels are being actually traced and half of them are being just filled from the neighbors. So we have aliasing, but we don't have ghosting. Now, what you can do also is you can not fill the neighbors at all. Where is this code? So this is this code. Now half of your pixels are not filled, but let me check if I have this in the shader or if I ripped it out. This is the wrong shader. This is the shader. Okay. Let's do this and let's do XOR shadow data checkerboard and one or something like this. That's weird. Shadow. No, I have to just sort a bit. So this will allow me to pass a different value on odd and even frames, so that we render odd or even checkerboard like tiles on alternate frames. And now here, is this like a boolean? This is a boolean. So if the boolean is set, we'll do frame index, we'll do 1 plus frame index times 2, otherwise we'll do 0, 1, 2, yeah, okay, this should work, I think. So, this works. So now check this out. Here, if I toggle between checkerboarding on and off, here's the status, you can't see any changes. This is because on odd frames, we render half of the pixels, and on even frames, we render the other half into the same target. And so if the camera is stable, then there's 0 issues because you have, after 2 frames, perfect information. But of course, the difference is traces take either 2.7 milliseconds or 1.8 or 9 or whatever. So you save performance by doing this. Even in this mode, I assume you can see this in the stream if you look here. If I move the camera, this now has a ghosting artifact because half of the pixels are stale from the previous frame. And because it takes a frame to catch up, you kind of are permanently late. If you launch the animation, I'm assuming we are going to see the same problem. Let's see. You see a little bit. It's a little hard to see though. So interestingly, in animation, maybe it's just too slow, and because like it's a large screen and stuff, I can barely see this actually. It's gonna be hard to see. Interesting. The bike structure is also oh. Was this the camera? Yeah, this was just the camera. Yeah. Maybe the motion just has to be way faster. So if you have the animation time that we are advancing, let's just speed up the animation 10 times. And then I think we'll see the same artifacts. But interestingly, they're not that pronounced compared to the camera motion. Yeah, okay, so now you can see it's like the same problem, right, around here. Where you see ghosting of the object because you only update half of the pixels every frame. So this is the thing where I was saying, okay, now if we do TA and then we have motion vectors and then we can use motion vectors for the same type of reprojection that TA is doing but just for the shadow traces, then hopefully we can have our cake and eat it too because, well, sort of. So, maybe, because like the aliasing issues are visible in motion as well, but they're visible in some cases even without checkerboarding. So here, both of these look the same to my eye. I'm against switching between checkerboarding on and off, and then trying to see if one is worse than the other, and like they seem exactly the same to me. It's like this is a problem, right, that we should fix, but it doesn't get worse by doing checkerboarding, and checkerboarding is 2 times faster. However, this type of artifact here, you can only see with checkerboarding because of the temporal issues. So this is where the hope is. If you do 2-frame TA, I'm going to try to reduce all temporal stuff that I do in the future to like a very small number of frames. But if you do 2-frame TA and 2-frame shadow TA, then the hope is you can have the performance gains and you can have no ghosting and you can have the same amount of aliasing that you have. So that's like the plan, that's the hope, and that is why we did all of the work that we did today to do this beautiful thing, except that, you know, if the animation is not sped up, it's actually invisible. So until we actually have, I mean, yeah, like I'm not gonna commit any of this until we actually have the TA set up. We can't really do this because we have ghosting. And I'd rather have aliasing than ghosting, I guess. So there's that. But that's kind of it. So follow-up stuff. I have some notes for myself. This is the biggest surprise. RADV doesn't seem to have refitting code at all. I did not expect this. And then some validation stuff, and then some GLTF stuff that I might take care of. I'll probably just add this to do and then do it sometime in New Year. So that is kind of it. Let's see if there is any further questions in chat. Overlap ray trace compute after the build on raster. Oh, I see. The problem is you can't do this because you don't have the race to trace yet. Because the problem is, do I still have, yeah. The problem is, wait. Okay, so this is where we do the traces. However, to start doing the traces, we need a position to trace from. And the way we get the position is by taking the depth data from the G buffer, which we fill here, and then tracing array in the shadow direction. So we can't start ray tracing until we do this. So these are not overlappable. Similarly, this is the blurring stuff. And so that has to happen after this. This is the terrible thing I was talking about where some rays just take forever. I'm not sure why they take this forever, but this is also traced from RADV, not traced from the official driver, so I don't know how much you should trust it, blah, blah, blah. But yeah, this is the kind of, it would be great to do something useful. A, it would be great for this gap to not exist. B, it would be great to do something useful during this gap. Unfortunately, we don't have anything to do because, you know, we are close to the end of the frame, but we need shadows to finish it. To do shadows, we need to do blasts and TLAS and stuff. We can't even update TLAS for the next frame because we can build a new one, I guess, for the next frame, but we don't have double buffering. So there's like, there's a lot of problems in this frame, but none of them are super obviously solvable to me, except for overlap here. But again, this is the RADV update. The AMD driver update would be like small. And so until we have to do full builds, which I'm not sure, whenever we have to do full builds, we'll do that. But until we have to, RADV has to be fixed. This is not normal. But when it does get fixed, this issue will disappear. And so again, don't solve problems you don't have. We have a problem, but solving this problem is not on us right now. So yeah. And there's definitely some other stuff. I mean, like there's some stuff in this frame that could be better, of course. I honestly, it's been like a little while since I looked in some of these details. Some of these gaps, I think this is our pyramid shader, yeah? Presumably. This is half of it. No, this is not. This is the pyramid build. So the pyramid build could be shorter because this stuff can be fixed by using single pass downsampler. I think this is the second pass call that is basically calling a bunch of objects and then rendering none of them because everything is fine already, which you can slightly optimize in some of these places. I might talk about that at some point in the future. So there's like a little bit of slop here. This is 40 microseconds is the problem. So even if you can cut the slope in half, you will get 20 microseconds. So like it can be a little bit faster. It's not a whole lot. The biggest performance issue is this one. This one, I believe, happens in the AMD driver, official driver, just not, maybe it's not as large of a gap, but like this is still a problem. This obviously is a RADV specific thing. I'm just shocked they don't have refits. I did not expect this. Let me save this just so that I don't forget. Yeah, like the word refit doesn't happen. They always do the smart and sort thing. It's just everything points. Why do they even care about the updates, I wonder? Yeah, and so this is why the stream crashed. This is the thing I was talking about. The flags determine the BVH structure, and you can't, it should be impossible for you to mismatch the flags. The spec is worded in a weird way here. Well, or rather, this is RADV code actually. It doesn't, for TLAS, it's always the same type. But for the official driver, which is where we crashed, if there is a different type, it would be a problem. So then if you don't need a fast build and you don't need updates, it does also plock. And it does LBVH if you need fast builds or updates. But it's all not for classes. Oh, it might be that they have code to update this guy and they use this code for BLASes, but they don't have code to update this guy, which is a different structure type, different algorithm rather for building. And so they rebuild from scratch. So if the mode is update and is bottom level, then they do an update. Yeah, see? So if the mode is update and it's top level, they don't trigger this at all. So it sort of looks to me as if RADV always rebuilds TLAS. BLAS, you can update, TLAS, you can't. Which again, I will not spend 0.75 milliseconds on updating 3,000 objects. That is insanity. But that's how things are. Okay, so I will file a bug on this in RADV. I don't know why this is how it is. But did this regress? I'm using a very latest Mesa. They changed a bunch of code around builds to migrate it to like shared framework with other drivers, which is good long term. I'm wondering if the logic is exactly the same or if it was different. Anyway, I will file a bug and they will figure out what to do with that bug. But it's just too much. It's just too much. And the official driver doesn't have this problem, so there should be an expectation for an application that this is not a problem. Okay? So I think we're done with this. Thank you, people, for attending the last stream of the year, the last Niagara stream of the year at least. Sorry the stream crashed, but well, you know, at least I didn't have to reboot my entire computer and stuff like this. Sometimes when this happens, the process gets killed in like tens of seconds, but in this case, for some reason, that didn't happen. And so I don't even know how I fully recovered from this, or like what killed it, the offending process to begin with. I was like pressing random buttons and seeing the screen updated like once every 5 seconds, so that was fun. Okay, future announcements of future streams are gonna happen in the new year. Happy holidays to everyone, and I will see you in 2025.